Okay, so I think it's being recorded now. And yeah, if anyone else wants to have a backup recording, please feel free to do so. Thanks, Linda. So yes, so that is basically how the evaluation is. Okay, and we have our midterm and we have our final exams. And as we get closer to the midterm, and of course the final, I'll provide more details for how we're going to be doing things because of the fact that this course is online this year. We're going to be making a few changes to how we do our midterms. Traditionally, just to give you a bit of background, this entire course 1320, this entire course was traditionally a handwritten course in terms of tests and quizzes and midterm exams and final exams. So previous students in this course had to answer all of their tests and exams and everything just using pencil and paper. And that might feel extremely primitive and ironic, considering that we're trying to be a modern web development course. But testing is a challenging problem. And one of the ways that we try and confirm whether you really understand something or not is if you can basically just go to a whiteboard or something like that and write out the answer. We don't have those same sort of options anymore because it's online. And so as we get closer to our evaluations, I'm going to discuss how we're going to evaluate things. If there's any questions about course policy or the course itself, feel free to ask right now before we move on. Okay. Sounds good. So if there's no question.
Excuse me, Arman.
Yep.
I can't record the session because it tells me to ask for the permission from the host.
Oh, okay. So I'm currently recording right now, or at least it's telling me that it's recording. So hopefully that's going to work. I don't get any notifications from you or Zoom rather about recording. So maybe I'll have to ask like the admin to allow students to turn on recording. Okay. That might be something I have to turn on. But yeah, it should be recording right now.
All right, thanks.
Yeah, so all right. I'll just check chat from time to time. Okay, so things we need for this course. So I don't know if you already have Visual Studio Code installed, but if you don't have it, have some kind of editor where you can write code, okay? And does everyone already have VS Code installed on their computer? I don't know if other courses already made you do that.
All I have installed is the Node.js that you asked us to install.
Okay. So in your web development, one course, what are you currently using right now? Your course 1171. Has Adnan already specified to you guys what kind of code editor he wants you to use? Have you,
No, we just done an intro class.
Okay, so that's fine. Then if you don't already have it installed, some of you might have it installed, but if you don't, I definitely want you to install Visual Studio Code, which is the program we're going to be using for writing code in this course. Now, if you for whatever reason, if you don't want to use this program, perhaps because you have your own text editor that you like, whether it's Vim or Emacs or Sublime Text or some other, or WebStorm, whatever it might be, if you have your own code editor that you want to use, that's fine. But if you don't have any preference or don't even know, then I would suggest just using this tool here. Okay, I've already posted it in chat, in Zoom chat. So go ahead and download this. And the other thing you're going to want is Node.js. Okay, so Node.js, you go to the website. I'm on a Mac, so it's suggesting for me a download for Mac, but whatever operating system you have, go ahead and download the current version of it. Okay, so you're going to have two options. Go and download the current one. If you've already downloaded it and you downloaded the LTS, which stands for long-term stable, if you downloaded the LTS version, that's fine. Later in the course, I'm going to require you to upgrade to version 14, but for now, it really doesn't matter. Just have one of them installed. If you haven't installed it yet, download the current version. Okay, if you already have it on your machine, that's fine. It's probably going to be all right. Okay, so those are two pieces of software that I want to make sure you have installed. And the final one that I want to make sure you have installed on your computer is Git. Okay, so if you don't know where to find it, you can just go to Google and just type Git, G-I-T, go to the main web page over here, and download Git for your operating system. So you can see over here, it says download, et cetera, et cetera, et cetera. Go ahead and download it, okay? When you install Git, and this is especially important for people who are downloading Git for Windows, okay? When you download this and you are clicking next, next, next in the installer, there's gonna be some part in the installation where it asks you, do you want to install Git Bash? Okay, there's gonna be some check mark next to the word Git Bash, and that is Git BASH. You're gonna see something like that. And make sure that that is checked, okay? So if it's not, make sure it is checked. For the most part, you can just go with the defaults that it provides you, but just make sure that if you see this word bash anywhere, just make sure it's checked. And so those are the three pieces of software that I request you have downloaded and installed on your computer, okay? And we're gonna be getting into them in this lecture, but I just need to make sure that you have them installed. Okay, so what exactly are we doing? Well, traditionally, what we've done in this course is I've started by giving let me put on my video. I've started by giving an introduction to programming and the entire field as a whole. But you see, the problem is that with this group, we've lost a week, right? We've lost a week due to the orientation. And losing a week in this course is like losing a year of material in another course, right? You really don't want to miss a week of material in this course because there's just so much we have to catch up to. So that's why I'm going to keep the intro very brief so that we can, as soon as possible, jump into the actual content for this course. Okay, so the main goal that we're trying to accomplish with this course is you want to be able to walk out of this course being able to write a program that can solve some problem that you have or some problem that someone has. You want to be able to write a program, and then you want that program to be able to actually work when other people use it, right? So ideally, you can give that program to someone else and they can use it, they can run it. Now, when I use the term program, I'm not saying you should be able to make a website. I'm saying you should be able to make a program, okay? And that's not the same, that doesn't mean the same thing, right? So if we go ahead and jump back for a moment to our course outlines, I'm gonna go back to Full Stack Web. You're gonna see here the name of this course is called Introduction to Software Development, okay? And you also have a course called Web Development, okay? Now, if this program is all about full stack web development and the focus is on the web, can anyone explain to me why, just if you had to take a guess, why would we bother learning software development if the whole point is for us to become web developers? Can anyone take a guess why that's the case? Or maybe even take a guess of what the difference is between web development and software development. Okay, so you see, this is a very quick minute I'm gonna give all of you on the history of things. And what I'm about to describe in this next 2 minutes is something that actually used to be an entire course that it would take to explain this, but I'm gonna try and condense it into 2 minutes instead of 15 weeks. So you see, most software that we have on our computers, right? These are programs that we download, or in back in the day, we'd go to a store and buy a disk and put that disk into our computer and then install that software. And if we're thinking of traditional software, we have programs like Microsoft Office, so Microsoft Word, Google Chrome, which is a browser, Visual Studio Code, which is a text editor that I just downloaded. If you've ever used any media players on your computer, whether it was Windows Media Player or VLC Media Player, any of these things to watch movies on your computer, and even Zoom, right? Zoom, which is what we're using right now, Zoom is a piece of software which is installed on our computers. When we talk about software being installed on our computers, we are talking about a program that you download, you install, and it runs on your operating system. And the code in that program, the code is communicating directly with your operating system, okay? And what I mean by that is when I am using this Zoom program that I have open right now, the developers of Zoom, when they wanted to make this piece of software, they wrote code in some language, whatever language it is. They wrote code in some language that allowed that program, Zoom, to talk to the user's computer, and specifically to the user's computer hardware, okay? Now, this is how it was for a really long time. And for a very long time, there was basically two ways that we could talk about software, okay? The first kind of way we could talk about software was the way I just described. Stuff running on our computers, like Zoom or Internet Explorer, whatever it is. And the other thing we could talk about are websites. And websites are things like what you're looking at right over here, right? We have to have a web browser so that we can actually look at a web page, okay? And we can basically read content, read information through our browser, okay? Now, over the last 5 to 10 years, there's been a massive shift in the ways in which companies produce software. In the last 10 years, there's probably been the biggest jump from how we used to write software and how we write it now. And that jump is a jump which is known as cloud computing. Now, this is a big topic, and as I mentioned, it's an entire course, and so I'm not going to get into the details of this right now, but here's the bottom line. The bottom line is, nowadays, browsers are fast enough to be able to run software that we used to have on our computers. Browsers can now run them as web pages, okay? And that's a really important thing to understand, right? Because if you think about programs like Gmail, right? When I use something like Gmail, or when I use something like Dropbox, these are programs that we used to just have to run on our computers, right? So over 10 years ago, we used to install some kind of email client on our computers. I mean, I even have one right now, some sort of email program, and we'd use that for checking our emails and all that kind of stuff. Browsers have become so fast now that most companies these days decide to just release their applications, their software, directly on the browser. Now, the reason that you want to release stuff on the browser, the reason that you want to write software for the browser is because of one specific reason. And that reason is cross-compatibility, okay? If I write something like Zoom for the Mac as a traditional piece of software, I have to rewrite that same piece of software now for Windows. Okay, so I have to rewrite that entire thing for another operating system. And traditionally, that's how it's been. If you, in the past, went to a store and you wanted to buy some virus cleaning software, or you wanted to buy Microsoft Word, you'd buy a disk, and that disk would either be for Windows or for Mac, or Linux perhaps. But Microsoft Office isn't on Linux. So for Windows or Mac, you would have a disk. And the problem with this is that you have to have a software team that's twice as large, because you need people who know how to write software for Macs, for Mac OS, and people who know how to write Windows software. Now, the thing about a browser is everyone in the world already has one. Everyone in the world has one. And because of that, if you write applications that work in the browser, you don't have to worry about the operating system that someone is using. You don't even have to worry about if they're running it on a phone, Because if you think about phones, now you have to go and make applications specific for Android, and then another application for iOS, and then a Windows version and a Mac version. Writing the same piece of code 4 different ways is a huge, huge time waster. And it also costs the company tens of thousands of dollars to hire developers for each of these platforms. And so the reason that the web has exploded in the last 5 to 10 years is because browsers have become powerful enough that we can take all of the stuff we used to do just on our computers, and we can put it all on the web. Okay? And so this idea of full stack web development is running things in browsers. But the thing that you need to know is that the fundamentals of it all still come back to software development. Okay? And so we are definitely going to be working with the web in this course, especially in the second half of this course. We are going to be working with the web. But before we do that, we're going to be understanding things at a more basic level, just talking about software that's running on our computers. Okay? So is there any questions about that before I move on? Okay. So hopefully you have Node.js and Visual Studio Code installed so you can follow along. Now, if you don't have these things installed, don't worry. Just follow along for this lecture with my screen share. And when we take a break, you can go ahead and install these things. Okay, so I'm going to shift gears a bit. And so what I'm going to do is inside my documents folder, if you take a look here, I have a folder I've made called Full Stack Web Development. Okay, I've made this folder called Full Stack Web Development. And what I want you to do is I want you to open this in VS Code. Okay, if you don't have VS Code installed, then as I said, just follow along for now. Okay, so I'm going to go ahead, I'm going to take this folder. And if you're on Windows, you can just drag and drop it into Visual Studio Code. So here I have this folder. Now, the reason that we're using a tool like Visual Studio Code to write our programs, the reason we're doing this is because programs have a special syntax to how they're created. In other words, there's a special grammar that we're going to use to write our software. And the problem is that text can be formatted in different ways and understood in different ways. Okay, so let me give you an example of what I mean. Okay, here I have this Visual Studio Code program installed. Okay, and I'm going to go and type the word hello. And inside of this word hello, I'm going to put quotations. Okay, so you can see here, I've put quotations. Now, you'll notice a few interesting things about this, like the fact that it puts color in this word. When we start having a lot of code, it's going to be really difficult to read it if all of the code is gray or black. And so the first thing these editors are going to do is they're going to add a bit of color. Now, the second thing these editors are going to do for us is you'll notice that as I continue to write code, these editors are going to give suggestions to me. And the idea is that instead of you having to memorize all of the different things you need to know for programming, these editors, these text editors are going to help you so you don't have to memorize them. They're going to give you intelligent suggestions so that we can just pick the things we need instead of having to memorize each and every single little thing. Okay? So that's another major pro to using these editors. Now, the last thing that I want to mention is, let's say that I use something like Microsoft Word or TextEdit or something like that. So you can see here on my Mac, I've opened a program called TextEdit. Okay, so you can see here, this is a simple text editor. If you're using Windows, it's something kind of like WordPad. It's just an alternative to Microsoft Word. And you might ask yourself, what if I don't care about the color highlighting and the suggestions? Can I still write code in an editor like this? And the answer is you can, but you shouldn't, okay? And there's a reason I'm going to show you why you shouldn't. I'm going to take this same word hello over here, okay? And I'm going to surround it with those same quotations. Now take a look at what just happened. Did you see that for a moment, the quotations were kind of these square-shaped quotations, and then they turned to these angular ones. So if you take a look very quickly, see how it changes, okay, that change. This is a special thing called rich text formatting, okay? So when we work with things like Microsoft Office, or so Microsoft Word, or traditional editors like these, where we write essays and things like that, the thing is that these have been designed for us to write English or, you know, or Japanese or Spanish, basically human languages. And the unfortunate thing is human languages sometimes are quite different from computer languages. And this is just one simple example. A computer does not understand what this kind of curved quotation means. It understands this square one, but it doesn't understand this curved quotation. So if you take this code here and you send this code to some sort of thing like Node.js or something to execute the code, your computer is going to say, I have no idea what this means. But your computer will understand what this means, okay? And that is the reason why we use special editors that are designed for programming, okay? Because these editors have already been configured so that we can so the computer can understand what we're typing. Okay, so that is the motivation for why we're using these editors. Okay, any questions about that and about the fact that we're using VS Code in this course? If your other instructors tell you to use something else, that's fine, doesn't matter. Okay, but we are going to be using VS Code in this course. Okay, now let's get started with writing some programs. So the thing that we're going to be doing in this course is we are going to be writing programs using the JavaScript programming language, okay? And the JavaScript programming language, we're going to get much more into that in a bit. But for now, all you need to know is that when you're working with Node.js, this thing that we installed, by installing this program called Node.js, what we're doing is we're installing something on our computer, something called Node.js, which is going to allow us to write code in this editor over here. We're going to write code using the JavaScript programming language, and we're going to send this code, we're going to send it to Node.js. Okay, so we're sending it to this thing that we installed called Node.js. And what Node.js is going to do is it's going to translate that code to something that our computers, our CPUs, will be able to understand. Okay, so that is all we need to get into for now. So how can we actually go ahead and start writing some programs using the JavaScript programming language, programs that we can send to Node.js? At the end of today's lecture, I will discuss all the things that are going to be quizzed and are going to be tested. But the safe assumption you should make is that anything that I discuss during a lecture is something that could be on a quiz. Okay, so that's a safe assumption you should be making. Now, the first thing we need to understand is that all a program is it's a bunch of sentences. And if you think about it, that's not so different from English, right? Because in English, I can have a sentence. So here's my first sentence. And after this sentence, I'll put a period. That'll be the end of the sentence. And then I can go ahead and make another one and another one. And sometimes they're long sentences. Sometimes they're short sentences. But the point is that when we write things in English, it's basically, or any language really, it's just a sequence of words that we're stringing together to make sentences. And in order for us to actually write sentences in English, we need to have some concept of, you know, what we can write and what we can't write. And it's the exact same thing for programming, okay? In programming, we have certain kinds of ways we can work with data. And we need to understand all of these different ways we can work with data so we can make complete programs, okay? So the simplest sort of thing we can do is we can work with numbers, okay? Computers are really good at this, okay? So these are some of the different kinds of data you are gonna find when you work with JavaScript, okay? The first kind of data that you're gonna probably see is a number. Now, it's important that you keep in mind that what I'm telling you right now is not universal. if you move to Python next term, which is a different programming language, okay, these concepts, while the concepts will be the same, these different kinds of data that we can work with are not necessarily going to be the same. Okay, so what I'm teaching you right now is not going to be exactly the same in every programming language. That's why I'm saying that we're focusing on the JavaScript programming language. So I've created this file here, right? And I've given the end of this file name a .js extension. And what that means is this file here is going to have JavaScript code in it. I'm going to put JavaScript code in it, and then we're going to give it to Node.js. Okay, so the first kind of JavaScript code we can work with is numbers. And there are two common numbers you're gonna see in everyday life. The first kind of number you'll see is a regular whole number. Okay, so we can call these whole numbers. We can call these integers if we make them, have, a negative to it. But the point is that this kind of number does not have a decimal after it, not something like this. It's just a whole number like this, okay? That's the first kind of number. The second kind of number that you're going to see is a number that has a decimal in it, okay? Now, we usually call these in programming floating point numbers, okay? But the name doesn't matter too much. You just need to know that there are two ways we can represent numbers in JavaScript. Now, something that you're going to learn about later in your math class, you're going to learn in your math class about the fact that computers actually do not understand the meaning of decimals. Okay, computers don't understand this concept of a decimal. And so internally, this decimal number here is actually a whole number to the CPU. And because of that, in JavaScript will regard whole numbers and decimal numbers to simply just be called numbers, okay? And that might be a little bit strange to you because in regular math, when we talk to people, we always say, this is a whole number. And to other people, we'll say, this is a number with a decimal, right? This is a decimal number. That distinction between whole numbers and decimal numbers is not so obvious in JavaScript. JavaScript just calls these numbers, okay? So we have numbers. That is the first thing that we can do in our code, okay? So our computers will be able to understand this. Now, the next thing we can do is we can take strings of text and we can actually do things with these strings of text. Okay, so I could put, for example, the word hello, or I could just have a letter like H. Okay, and so when we want to have words, actual words represented in our data, that's where we're using these quotations, okay? And so the name for these is what we call strings, okay? And so we're going to be coming back to these in just a moment and understanding some of the different ways that we can work with this data. I'm going to be showing a few more in here, okay? And so we also have this concept in programming of the notion of something being true or something being false, okay? And I understand these are all very abstract right now, but we're going to give examples to make this clear. The point I'm just trying to show you is different ways of representing data, okay? So we understand that we can use numbers. We can use strings if we want to express some kind of word or perhaps a sentence, like my name is Armand. Sometimes we want to express that something is true or something is false, okay? For example, I might want to express in a piece of software that the number 18 is greater than the number 5, okay? So I might want to express this concept. And so if I want to express that 18 is greater than 5, I can use the keyword true to tell a computer this number is greater than this number over here, okay? And that's essentially what the concept of truthness or falseness is. That something is, and there's going to be many ways that we can do this, right? So we can also say something like the name John is equivalent to the name John. These two are equivalent to each other. In fact, they are the same. And so because these two are equal to each other, again, I might want to say that this is something which is true. And so that is another way we can represent data, something being true or something being false. Sometimes in a computer, we're going to want to say that we want to express the absence of data, okay? This is something we're going to come back to, but there are times when we're programming and we want to say that we don't know what the data is right now. We're not sure what it is right now. Maybe in 30 minutes, we're going to know what it is. But right now, at this point in the program, we don't know what the data is. We don't know whether it's 42 or whether it's a sentence like this. We don't know what it is. And so we also have these concepts of null and undefined, these concepts that express, hey, right now, I don't know what the data is, but I'm going to know about it a little bit later. So sometimes we want to express the fact that we don't know what the data actually is. And finally, we have these ways that we can express collections of data, okay? And when I say collections of data, I mean taking data like this, like numbers or strings of data, taking each one of these and grouping them together. And so, for example, here, I'm taking this concept of a number and I'm grouping all of them together. And this grouping here forms a list of data or an array of data. Okay, and so this is how I can take a whole bunch of different kinds of data and group all of it together. Okay, so this is the basic idea of all the things we're going to do with programming. The idea is that we're going to be taking data and we're going to be constantly working with it, changing it in different ways, adding to it to create full-size programs. Okay, so let's start with some simple things that we can do with this data over here. Okay, so the first thing I'm going to do is I'm going to go and type 3 plus 4. So here we have two numbers and we're adding them together, right? This addition operator is just like the addition operator that we have in math. And so what I want to do with this program is I want to tell my CPU to add the numbers 4 and 3 together. I might also want to tell my CPU that I want you to take the number 2 and multiply it with the number 2 again. And I might want to say take the number 6 and divide it by the number 2. Okay, or the number 5 and minus it from the number 2. I want my CPU to execute these 4 different instructions. So this is JavaScript code, and we are going to tell Node.js to take this code and send it to your laptop's CPU or your desktop CPU. Now, how can we do that? The way we can do that is by first sending this file to Node.js. Okay, so this file has code in it. And we are going to give this entire file to Node.js, and Node.js will translate it to something our computers can understand. How can we send this file to Node.js? The way we're going to do it is using this concept of a terminal. Okay? Now, a terminal is essentially just a black box window into your computer's operating system. And the thing that you can do with terminals is you can call software that doesn't have an appearance, a visual appearance to it. So as an example, right, when we're working with websites, we can see everything in the browser, right? It's all visual to us. The program itself, the browser, gives us some sort of visual thing we can look at. But not all programs are visual, right? Not all programs have buttons and things like that. Those visual aspects, like adding buttons and colors and things like that, that is something that we're going to do later. Okay, we're going to add those visual aspects to our programs later on in the course. But right now, we simply just want to run this program and just see the result without any buttons or any things that we can click. We just want to see what Node.js gives us back. And the way we can do that is by opening up this concept of a terminal where we can write Node and then give Node the name of the file that we want it to run. Okay, so as I said, Node.js, which is the program that is going to translate our code to something the computer can understand. Node.js needs to be given the name of a file. And once that file is given to Node, it can run the code in that file. But Node.js is not like Zoom or not like Facebook or any of these programs that have a visual interface. we have to use this ugly looking black box interface, this very primitive looking interface, in order to get the Node program to start. Unfortunately, we cannot just double click, Node.js here and have it start up. The way we have to run the program is through this text-based terminal, okay? Now, as a trick, what you can do is you can use the terminal that comes pre-installed with Visual Studio Code. So Visual Studio Code has already inside of it a terminal. And a terminal, remember, is that black window where we can turn on Node.js. And we can tell Node.js to run this file. So if you press the following keys, Control plus, and then this key over here, the tilde key, if you press these two together, it will open the terminal on your Visual Studio Code window, okay? The tilde key is the key which is next to the number 1 on your keyboard. So if you look at the number 1, to the left of the number 1 is that tilde key. Okay, so I'm gonna press Control tilde, and you can see here that this terminal has popped open, okay? It's popped open, and what we're gonna do now is we're gonna tell this terminal, start up Node.js and run this code. Now, before I do that, I'm gonna make sure I've saved this file. So the file has been saved, and I'm gonna run it. And when I press enter, you see nothing. Now, the reason that you see nothing is not because the code didn't work. Our computer did understand all of this code. This code was perfectly fine. But the reason that we had an issue is because when our computer runs this code, we need to tell our computer to take the result of running this program, take the results, and show it to us. We need to actually see it. We want to see it over here. And so the way we're going to do that is we're going to tell Node.js through JavaScript, take this stuff and print it or log it to the terminal. Now, there are many ways we can refer to this concept of a terminal. Here are some of the words you'll see. Sometimes it's called a terminal, okay? Another word for it is a command prompt, okay? And depending on what operating system you're using, there's going to be many, many words for it. Another word for it is console. These all mean the same thing. They mean this black box where we can start up our programs. So JavaScript uses this word console, okay? And what we want to do is we want to print code to the console. We want to log the result to the console. So what we can do is we can type console.log, and then we want to wrap this code in parentheses like that, okay? And I'm going to do the exact same thing with these ones as well. So I'm going to put console.log, and I'm going to, again, wrap it with parentheses. And I want to make sure that I close each and every one of them. Now, this program is going to work. However, it's not complete yet, because we're going to be trying to write code that uses correct JavaScript grammar. And what that means is, even if our code runs, even if our program works, we want to make sure that our code is clear and easy to understand by other people, other developers. So anytime we finish a calculation, a statement, we're going to put a semicolon at the end. Okay, so each one of these is going to have a semicolon at the end. I'm going to go and save, file, save. You can see that our file has now been saved, and I'm going to go ahead and type node app.js. When I press enter, you can see each one of these calculations showing the same thing you would see on a calculator. Okay, so the program is working. Okay, it's able to do basic mathematical calculations. Now, let's go ahead and break this down a little bit, okay? Because there's a lot of stuff that's going on over here. So we have numbers, and we learned that we can use these different operators, just like on a calculator, to be able to do basic math with these numbers. Okay, so these should not be too surprising for us. We can add as many as we want. There's no limit, okay? So I could go ahead and add a +2, and then a ×2, and then a ×4. There's no limit to how many of these I can put. And you can see that the result, when I type, again, node app.js, and I press enter, you can see now that it's 23, okay? So we can put as many of these as we want. This second part over here, I'm going to delete this for a moment. You'll see that we wrapped everything inside a console.log, okay? So this is what we call a function, and we're going to be coming back to this concept of functions later. But essentially, this is some special JavaScript code that comes baked into the language. So we don't have to worry about how it's possible to do this. Just know that it exists in the JavaScript language. JavaScript has this concept called console.log. And if you write this command, you can take whatever you put inside these brackets, in these parentheses, these brackets, you can put anything, and it's going to be printed out to the console here. So remember how earlier we talked about things like strings. So I can go ahead and put a string here, and when I save and run this, that string is going to get shown inside of our console, okay? Now, the important thing that you should do is whenever you're working with data, you're going to want to ask yourselves, what kinds of things can I do with this data? So let's take, for example, this multiplication operator over here. Does 2 times 2 make sense to us? Yeah, that makes sense, right? 2 times 2 should give us 4, and it does. But now let's ask ourselves, what happens if I do hello times hello? So I'm taking a string, and I'm trying to multiply these 2 strings together. Does this make sense to you? Do you think that this should work? Let's go ahead and run this program. And you can see that JavaScript gives us back NaN. This is just a special way of JavaScript saying not a number. And that makes sense. NaN, or not a number, means JavaScript is saying, what on earth are you doing? You know, these are not numbers. How can you do math with words? That doesn't make sense. So most of the time, basic logic is going to apply. It doesn't make sense that I can also divide a string by a string, right? That doesn't really make sense. So that is just something I want you to keep in mind when you're experimenting with these programs. Now, there is one exception to this rule. And the exception to this rule is the plus operator. Because the plus operator is actually doing double duty, okay? It actually has double the capabilities of other operators. Because what plus can do is it doesn't only work with numbers, right? It can also work with strings. Now, if I take the word hello and I stick it on to the word hello again, it's just going to create a new string that has the 2 of them stuck together, right? So it's the same thing as writing this, joining these 2 strings together. There's a technical term for this, and the technical term for this is called string concatenation. This is the technical term. You don't need to actually remember this term, but you should know that it is possible for us to join words together. Now, the problem with this is when we join strings together, JavaScript is not very smart, right? What JavaScript is going to do is it's just going to stick them together. It doesn't know about English or any other language that uses spaces. So if we want to add a space, we're going to have to explicitly say to JavaScript, add the word hello, then go ahead and add a space. See, this is a space. And then go ahead and add John. And if I go ahead now and I run this, it's going to say hello, John. As an alternative, I could also have done this. I could also have said hello plus and then put a space over here. This is going to be the exact same result. I see hello, John. Okay, so we can do basic math. We can work with strings that have actual words inside of them. We can also work with comparisons, okay? Now, what do I mean by comparisons, okay? Well, what I mean by comparisons is we have special operators in the JavaScript language, things that tell us if something equals something else, or if something is greater than or less than something else. So let's give a really simple example, right? If I want to compare if the number 4 is equivalent to the number 4, you might think that I'm going to do this. And JavaScript should give us back the word true, which means, yes, these 2 are equal to each other. Now, the problem is that this equal is actually reserved for something else, which we're going to get to in a moment. And so because of that, we have to actually do this, okay? Double equals. Now let's see what happens if I say, does 4 equal the number 4? It's going to tell me, yes, that's true. Now, what if I go ahead and I say, does the word banana equal the number 4? And the answer to that is false. Okay, and that makes sense. The word banana should not equal 4. Okay, let's do another example. Okay, let's say that I have the word hi. Okay, and I want to see if the word hi is equal to the word hi. And I'm going to go and run this, and it says true. Okay, so you can see how we're testing if things equal each other, if things are different from each other. Okay, and you'll notice that we keep getting back this word true or false. If you recall at the beginning, I said this concept of Booleans or truthiness and falsiness. We're going to be seeing this a lot in our code, this idea of expressing if something is true or if something is false. Okay, so now let's actually get a little bit more specific. And in about 3 minutes, we're going to take a break. Okay, so when I say more specific, what I mean is, what are the actual words, what are the actual terminology that JavaScript uses when it talks about these things? Okay, so when we are working with data, here is a whole bunch of data. I'm going to zoom out for a moment. Okay, so inside of JavaScript, every single piece of data that you work with, every piece of data has its own data type. And a data type is simply just a special word that says this type of data is a number, or this type of data is a string, whatever it might be. And the way we can verify this is by using something called typeof. Now, typeof is another built-in function that exists in JavaScript. Remember how we used console.log, and inside of here, we wrapped the parentheses, the brackets here, with something that we wanted to print out. It's the same sort of thing here. We can use this built-in function called typeof. And typeof is going to tell us what the data type is of all of these different things. Okay, so let's just experiment for a moment. I'm going to go ahead and run this program. So remember, I'm going to put semicolons at the end of each of these statements to say that this is the end of each one. And I'm going to run it. And you can see that, again, nothing shows up. Because remember, even if our computer runs this code, it's not actually displaying it to us. We need to see what the actual result of the computation is. And again, that is why we have to use console.log. Okay? We need to wrap each of these statements in a console.log. Now, I'm going to show you a little tip here. You'll notice that this is getting a little bit tiring because right now we're just learning JavaScript. And anytime we experiment with anything, we have to keep writing console.log, console.log, console.log. This gets really tiring when we're trying to learn something. I'm going to show you that it works, but then I'm going to show you a shortcut that you can use while you're learning. So I'm going to run this program, and it gives us things that are a little bit interesting, right? So it says that this value, 20, this is a number. This word here, this string, this is of type string, okay? And this word here called true, this is a Boolean, which is a way of expressing if something is true or false. Now, if I wrap this word true like this, it's no longer going to say Boolean. It's now going to say string because of these opening and closing quotations. And finally, I told you about these keywords we have called null and undefined, which are these keywords to express that we don't have any data yet. We have no value yet. It's a way of expressing that we don't have something. And you can see here how it says that it is of type undefined. Finally, let's go ahead and check out null. So I'm going to print out the type of null. And you're going to notice that I'm going to run it again. You're going to notice that it says object. So these ones probably made sense to you. It makes sense that this is the data type number. This is the data type string, right? That this is the data type for Boolean. But this one here might seem a little bit weird, because if this data type is undefined, then it makes sense that this data type here should say null, not object. And this is actually a bug. This is a bug in the JavaScript programming language, and it's a bug that has been around for over 10 years. The actual creators of JavaScript have admitted that this is a mistake, and it should actually show null. That is the data type of this, null, not object. But the problem is that this bug is baked into the JavaScript language. And millions of people around the world have accidentally used this code without realizing that it was a bug. And so the problem is that in 2020, if JavaScript decides to fix this bug and say that this data type is actually null, not an object, then millions of programs around the world will break tomorrow. They're going to break because suddenly our browsers and everything are not going to understand the fact that this is actually null, right? So we cannot simply just fix this bug. It's too deep in the language. But just understand that this is a bug, and in reality, the type of should be null, not object, okay? So that is data types, okay? And we're going to start actually working with these now. We're going to take a break, but before we take a break, I want to quickly mention one thing to you. Notice how we have our terminal over here, right? So this is our terminal. And I told you that it got really tiring to have to keep writing console.log anytime we want to experiment with JavaScript, right? This can get really tiring. So there's actually a shortcut that we can use. There's two. The first shortcut we can use is we can go into our terminal here and type the word node, but we don't give it a file name. And if we just write the word node and we press enter, what we've done here is we've jumped inside of Node.js. Quite literally, we've jumped into Node.js. And over here, we can type any JavaScript code we want, and we never have to write console.log. It's automatically going to do it for us. I can go ahead and add two numbers. I can go ahead and add two strings. And you can see how every single time I press enter, it's going to show me what the result is of that operation. Okay? So that's going to save you some time. Now, when you want to exit this, you have to press dot and then the word exit. Don't forget the period at the end. And then you press enter. And now we have exited. Notice how it looks different. This and this. Now your command prompt might look different from mine, right? Yours might look different. But the point is, these are different. When you are still inside this mode here, it says welcome to Node. You have to exit it when you are finished experimenting in this mode. Now there is another option you can use, and there is a program you can download which is called Run.js. And Run.js is a program that looks similar to Visual Studio Code, okay? It looks similar to Visual Studio Code, but the difference is it allows you, just like the terminal here, it allows you to run code without typing console.log over and over, okay? So as I write different expressions, right? As I write things like, this is a sentence. Every time I press run, it's going to run this code. And I never have to type console.log, okay? And so this is really great because we can experiment with all sorts of different things. Does 5 equal 5? Is 4 greater than 5? Is 3 less than or equal to 7? Is 3 less than or equal to 3? All of these things, I can just click run. And you can see over here the result, right? 4 is not greater than 5. That's false, right? It's given us back a Boolean. That's the data type, Boolean, false. And 5 is equal to 5. 3 is less than or equal to 7. And 3 is less than or equal to 3. Okay, so this is called Run.js. You don't need to download it. But if you want to, it's available for you by simply just typing run.js, and you can download it from over here. Okay, so that is one option that you have available to you. Okay, the simplest way that I suggest doing things is to just get used to working with your terminal over here. So again, just typing node and being able to do things inside the terminal right over here, and pressing .exit when you're finished. Okay, so we're going to take a break for about 5-10 minutes. So if you need to get a drink of water or anything, go ahead and do so. And let's say we'll be back by about 11:05. Okay, let's be back by 11:05.
Isn't it 11:05 in 1 hour?
Excuse me, I meant let's be back by before 10:15. Thanks.
Okay.
Looks like I'm gonna have to do some tinkering here because I didn't actually get the node to work on mine.
Yeah, me too.
The term node is not recognized as the name of a CMDlet. Yeah.
You're on Windows, right?
Yeah.
Yeah, I'm thinking, did you install Node as well as the Visual Studio on the same hard drive?
Yes.
Yeah, me too. I'm wondering if it's maybe not recognizing that it's installed in the right spot or something.
That's what I was thinking. So I uninstalled both of them and then reinstalled them both, but nothing happened. No changes.
Yeah, I tried the same thing.
This might be a wild guess, but you could try node.exe in the terminal. Python works the same, but I don't, yeah.
No, simply doesn't recognize.
Or actually, go to the same directory you installed Node to, and then try it there.
Yeah, I tried that as well.
Oh.
How do you change directory out of
The terminal?
Could you guys
CD.
could you guys go into like my computer and then right click on it and go into properties?
Yeah. Yeah.
And then go into advanced system settings.
Okay. Yeah.
And then go into environment variables.
Okay.
So you should see a list in the bottom. It should say system variables.
Yeah.
So look, there should be one called path, P-A-T-H. Click on that one and click edit.
Okay.
Do you see, I guess it should be to the bottom of your thing. But do you see something that says Node.js? So it should be, is it there?
Yeah.
So weird.
Yeah, Node.js,
Right,
program files / Node.js.
Yeah, yeah.
And then program files / Git as well. And then program files / Microsoft Visuals.
Yeah.
Huh, they're all in the same path.
Have you tried using PowerShell instead of command prompt?
What is PowerShell? I keep seeing
So
it.
just do open your start menu, just type in PowerShell,
Okay.
and then try running Node from there.
I mean, I can run Node. Like if I just open Node, you can do like 4+4. It prints out the right thing.
Okay. Yeah. Node.exe brings me to Node.js in Windows PowerShell.
Yeah, like Ryan,
When
if you try
when you-
opening Node, it should just work.
When you type in Node in PowerShell, what do you see? It should tell you the version.
Yeah, I got the latest 14.10.
Okay, that's so weird.
Yeah, for me it works too. If you go into PowerShell, it just works.
Visual Studio Code. doesn't,
kinda
which is
whack.
weird because I really
So
like.
is there?
Visual
There's got to be a way then to change a Visual Studio Code. You see where when you open your terminal, there should be a drop-down menu. So if you're on like Mac, it should say ZSH or Bash. You should be able
Change it
to
to
change it.
PowerShell.
You can
I-
exactly, yeah. You can
I only get
change the
one.
default.
I only get one. There's only one option.
Oh, shit.
PowerShell for me on there.
Yeah, PowerShell.
Oh, it's already PowerShell. Fuck.
Yeah,
Yeah.
that should be fine. You should be fine. Wait, what was the issue? I stuttered.
Yeah, it just keeps giving us a big red thing saying Node doesn't exist.
Can you share your screen so we can see?
Can you type
Yeah.
Node into that?
Yeah, give me a sec here.
They already tried Node Octavio, and it shows what it should show.
Okay.
I also noticed that when the professor was doing his little user was lit up blue, it said like full stack web development in blue, and you can also see how Ryan's here is like it's in white PSD/semester 1. It's all white, whereas the professor's was blue.
Yeah,
Hey, could you type in just Node, not Node.exe?
just Node.
Yeah.
Yeah, just Node.
Okay. Yeah. That shouldn't be happening.
Same thing with a lot of computers. That shouldn't be happening.
Are you? Seems like you're not in. Wait, is that your folder, semester 1?
Yeah.
Okay, never mind.
Yeah, it's an actual flash drive, but I've tried taking it off the flash drive and doing everything from the program files, and it doesn't work either.
Did you say that you're on Windows?
Yes, yeah.
Should it be app.js or apple.
I mean,
I mean, it doesn't matter.
I don't
I
think
don't
it
think
matters
it matters.
what you name the file.
I think I just read
fine.
Apple. Misread
Does
it.
apple.js
Something.
show under
It
semester
should
1?
recognize Node even without that.
Can you see my other screen, the Windows PowerShell screen?
Nah, can't see that one.
Well, yeah. Either way, the Windows PowerShell works. This one doesn't.
I think I missed the beginning of this. Is it in the variable path? Did you add no?
Yeah, I think I asked them to check that the first thing.
Okay.
And it's there, which is weird, Mateo.
Yeah.
Should I just like delete System 32 or something? Doesn't that help?
Oh yeah, absolutely.
Press Alt F4.
Not really sure what to do. I could just keep trying reinstalling them, but I might just have to use the PowerShell.
Did you install the correct version of it?
Of Node or of Visual?
Yeah, you said it was 14. I remember you seeing that. Yeah.
Yeah. Although I must say I didn't use the link for Visual from him. I used the one off.
Not Visual, sorry.
software.
Node.js, my bad.
Yeah, I got the Node.js and everything.
Yeah.
Wait, so Ryan, have you opened up CMD and tried to run Node from there?
Like the actual command prompt on the computer.
Yeah. Because I had a similar problem with Python a couple years ago.
Is it
I
just
don't cut-
node.exe? Yeah, it works there.
Okay, that's whack.
Where is it installed? Like, where
Yeah.
did you install Node.js? Is it on the 32-bit full, or is it on like just program files? Can you check?
Yeah, I'll double check here. Goodness. Where is it? Just let me search real quick. Yeah, Node.js is in program files. Is there something I'm supposed to check to figure out if it's 32 or 64?
No. If the folder says like x86, it's 32. But okay, let me check this thing. So, because mine's also installed on my 60 on just program files folder. So let me see if the path corresponds to that, which it should. But let me just double check. And your path was just program files and then Node.js, right?
Yes. Yeah.
There was no 86 in there.
No, not at all.
Ugh.
Makes things easy.
All right, we're gonna get started again.
Got my screen share.
There is 19 messages that I haven't checked in chat. I'm not sure if these messages are for me.
Oh, we're just doing some troubleshooting.
Oh, no worries. So one thing I want to mention about troubleshooting. There is a high likelihood that a bunch of you may have issues with installing Node and all sorts of different things like that. Unfortunately, it's not always the most straightforward experience. Because we're on a tight schedule, what we'll do is I will give time for us after lecture and everything to resolve any issues. And if we can't get them resolved, because I have, after our class today, right after our class during lunch, unfortunately I have a meeting and then another class, but all throughout this entire evening today, pretty much for the whole evening, I'm gonna be available on Slack. So if anyone has issues and needs like one-to-one support, I am going to be available all evening to help out with issues and stuff. Now, in terms of actually getting things working just for now, need stuff working immediately, which probably will. I recommend you go on Google and type it over here. So the website is called REPL.it or REPL.it, which I'll just throw into Zoom chat. And this is just a way that you're going to be able to run Node.js code without having it installed on your computer. Now, the thing about this is it's very temporary. And what I mean by that is it works and it's great, except when it doesn't work. And that's because we're essentially, what this website is doing is it's logging us in remotely to some computer that they have and allowing us to write some code which will run on their computer. Okay, so obviously the end goal is we need to get Node working on our own machines. But just for now, if it's not working, use this for now, and then in the evening or later on, if we have time in class today, then just contact me and we'll work through it. Okay, so yes, so that's REPL.it. Go ahead and use that if you need to use it. Okay. Okay, and there were some people who were asking, or I don't know, I think I heard something when I was coming back, something about like my terminal. So my terminal may look different from your terminal, right? And that's probably natural because if you've never configured your terminal, if you've never actually done anything to your terminal, it's probably going to look different. And so when I'm typing commands, I have certain things that I've done to my terminal to make my life a little bit easier. So for example, if I start typing a command that doesn't exist on my computer, it's going to show up in this kind of red pink color. And only when I type a valid command like node, then the color changes to green, which means that this is a valid thing that I can type. I also have things like auto completion set up so that I don't have to type out everything. I can just press the arrow key. So there's a lot of these things which we can discuss later in the course if you want to kind of modify your terminal to be a bit easier to work with. But for now, even if you have the most basic one that just works and shows the results, that'll do for now. Okay. So we've understood this concept of data types, right? And
your screen isn't being shared.
Oh gosh, I think I was showing things.
Yeah, I was going to say that too. But...
Okay, well then everything I just showed, hopefully you understood from my voice. Just to reiterate, can people see my screen now, by the way, or still not?
I don't think so.
I don't think so. No.
No, we can't.
Okay, no worries. You should
yeah, we can now.
Yeah, we're good.
So just to reiterate, I mentioned this site called Repolit. You go here, you click Start Coding, and you punch in Node.js. And that will allow you to write Node.js code, which you can run, even if you don't have it installed on your computer. Okay, so this was the first thing that I showed. And the second thing that I showed was, if I leave this, the second thing that I showed was the fact that my terminal actually looks a little bit different. So here's my terminal. And I was mentioning how some of the commands, I have a few nice things that I've added to make my life easier, like auto completion and stuff. We'll get to this later. Okay, if you want to have your terminal to have these kinds of features, we can talk all about that a bit later. But for now, the only thing that you need to have is the ability to run your Node.js programs. Okay, so that's all I have to say about that. So the thing that we've been doing up until now is we've been using console.log, and we've been putting data inside console.log, things like the number 45 or the word hello. And the thing about this is, while this works just fine, you can see that it works. Every time I want to reuse a piece of data, I have to keep typing it back in. Okay, and this is fine for small things, but if I have something like this, if I have something like 45 times 2 plus 3, you know, times 56, if I have some expression like this, and maybe this is some really important equation, some important thing that I'm going to consistently use over and over again, it's going to get really tiring to have to go and keep retyping this in everywhere in my program. Okay, and so the solution to this is to use a variable, right? And a variable is simply just a way that we can save our data inside a little box, right? And we have this little box, which we give a name, any name. And once we give it a name, for the rest of our program, we can always refer to that variable anytime we want to reference this data over here. And that is super, super useful. So if I go ahead and console log, I'm going to call this variable here, I'm going to call it important math. Okay, maybe it's some important equation. And what we're going to do is we're going to print this out, and you're going to see that it's the exact same thing. Okay, it's the exact same thing as if I just took all of this and I put it over here. There's no difference, okay? But it just saves us from having to consistently write these things over and over again, okay? There are certain things I'm not getting into right now, like coding style and how I want you to write code. We're going to discuss that later. But for now, just understand this concept of a variable is super important, and with it, we can save ourselves a huge amount of typing. Okay. We don't only have access to the variable for printing things out. We can do literally anything, because remember, this variable is the same thing as if I was to just copy and paste this somewhere. Okay, so let's go ahead and take a look at this. This thing called important over here, right? This thing, if we print it out, it's 258, right? So the number 258 is stored inside this variable called important. Okay, now one thing that you can do inside of JavaScript is you can go ahead and take a number and add that number onto a string. Okay, and we're going to be getting into these kinds of rules next lecture, but I'm going to give you a preview right now. Let's say that I have the number 45, and I add on to it 45. That's going to give me 90. Nothing surprising there. Okay, but let's say I go ahead and I say 45 plus, and I say hi. You can see that what it's done is a concept which we're going to get into later, as I mentioned, called data type promotion or type coercion. These are just fancy ways of saying that we can take a string and convert that string to another data type. In this case, we're converting this from a number into a string. And once this becomes a string, we're sticking that string on to the string hi. Okay, so this is this concept of type coercion, as I mentioned, and it's a really useful concept, because let's say we had something like this. Var a equals, I'll say 45 times 2. So I have something like this. And actually, using the word a is not very good. Let's give it a descriptive name. So I'm going to say var important equation, okay, equals, and now I'll say 45 times 2. So I've created an important equation. What I can do now is I can say something like this. The important equation you need to know is, okay, so I've got a string, and now I'm going to stick onto this string over here the variable important equation. And you can see that what it's done is it converts important equation, which is 45 times 2. It converts 90 to be a string. And once it's been converted to a string, it sticks that string on to this string over here. Okay? We can also do something like this. I can say something like var sentence equals, and I can take this entire sentence over here and paste it in. Okay? Then I can go ahead and say var new sentence equals sentence plus important equation. And if you take a look, if we take a look at new sentence, or I misspelled it, but if you take a look at it, you get the same thing. But the nice thing about this is anytime I want to refer to this result, I can just reference new sentence. A new sentence is going to hold this new sentence inside of it. Okay, so the point here is that variables are really, really flexible in JavaScript. Okay, they're very flexible and they're very useful for saving information that we want to use later. Now, the thing about a variable is there's actually two parts to it. So when we say something like var name equals Armand, this is actually a two-step process that we've simply shortcutted to doing in one step. But there's actually two things going on here. The first thing that JavaScript does usually is it creates a variable called name. Okay, and when I'm talking about a variable, the best way that I recommend you think of it is somewhere on your computer, you have RAM, right? You have memory. And the thing about that is because you have RAM on your computer, you have the ability to store all sorts of data, all sorts of things in that RAM. And I don't know if you've ever looked at RAM before on your computer, but if you actually opened up your RAM, you would see that it's this huge sort of area that has tons and tons of little spots where you can store data. Okay, and the thing about all these little slots in your computer's memory is your computer has a really funny way of referencing them. In your math class, you're going to learn about this, but in your math class, you're going to learn that if I want to get some piece of data from the memory of my computer, there's going to be some really confusing hexadecimal strange number, which is also going to be perhaps in some kind of binary number that's going to be really difficult to read. And if we had to remember every single time this confusing looking number just to go to this piece of data, that would be a nightmare. And so the idea is that with languages like JavaScript, instead of us having to remember this confusing sequence of numbers to figure out where in our computer's memory that data is, we can simply just use the keyword var. And when we do that, when we say var name, what JavaScript is going to do is it's going to pick one of these boxes. It's going to pick an empty box, and inside that empty box, it's basically going to say, okay, the word name points to that box. But the thing about JavaScript is JavaScript doesn't like empty boxes. Okay, whenever you create a variable like this, okay, and you don't give it a value, JavaScript isn't happy. It's going to say, no, I have to have something in there. There has to be some kind of piece of data in there. And because we didn't say var name equals, Jim or something like that, because we didn't do that, JavaScript currently has no idea what to put inside this box. And so what JavaScript is going to do when we simply say var name like this is it's going to store undefined in that box. Okay, and undefined is an actual thing. It's an actual data type in JavaScript. And the actual name of this data type is literally undefined. Okay, and so if we go ahead and experiment with this, I'm going to go ahead and I'm going to console.log name, keeping in mind that right now this variable has nothing inside of it. And when I do that, you can see that we get back undefined. Okay, so currently the actual type of data which is stored in memory is called undefined, and that means no data currently in that memory. So it's kind of weird if you think about it, that we have a piece of data to describe no data, but that is what undefined is doing over here, okay? Now, this over here, we have a word for this, and we call this variable declaration, okay? That is the name for this. It is called variable declaration. And this is where we declare or tell the program that we're creating a variable, okay? I have just written over here a comment. And this comment is just a way for me to explain what this line of code is doing. When you write programs in this course, you are definitely going to want to use comments. If you don't use comments in your code, when you give your programs to other classmates or other students, they're not necessarily going to know what your code is doing. They're going to have to call you or message you and say, you know, hey, Alex, or hey, Linda, what is your code doing? I don't know what it's doing. And that is why if you simply put 2 slashes like this, // you can go ahead and explain in a comment what your code is doing. My code below adds 2 numbers. Okay, so you can do something like this. And now when Adam or someone takes a look at your code and they see something like this, var add equals 4 + 4, presumably this is something more complicated, but they can at least understand what's going on because they can see this comment here. Okay, and so whenever you write a comment, the Node.js interpreter, the thing that reads your code, is going to completely ignore it. So when you write comments, JavaScript will actually do this to them. It's going to do this, and it's going to do this. It's going to delete them because it doesn't care about your comments. But for us, it is useful. And that is why I encourage you to use comments with 2 slashes like that, and you can write comment, okay? So this is what we call a variable declaration, And simply by declaring a variable, it doesn't have any data in it. That means that, and this is probably going to be a quiz question, but that means that this is currently undefined. That is the data that it has right now. Now I can go ahead and add data to it by saying something like this. Name equals, now I can say something like John, okay? And this is what we call variable initialization. Initializing a variable. When we initialize a variable, we're giving data to that variable, okay? We're making that variable have data. And you'll notice here that I've put an equal sign. There's also a special word for this as well. And the equal sign is what we call the assignment operator. And the reason it's called that is because what we're doing is we're taking the data on the right, we're taking this data, and we are assigning it or giving it to this variable on the left. And that's why we call it the assignment operator. Whatever is on the right is being assigned or given to the variable on the left. Now, even though you see this in 2 separate steps, we can shortcut this by simply doing this, var name equals John. And this is a very simple shortcut that we can use. We do the initialization and the declaration of the variable in 1 step, okay? So this is the idea of how we work with variables. And don't forget that at the end of every single statement that I make, at the end of every single one, I'm adding this semicolon. If you were writing an English sentence, unless you're on Twitter or something like that, you're probably always going to end your sentences with a period, right? This is a sentence. I'm going to put a period at the very end of it. And the reason is because English has rules. English and many other languages which use periods follow this convention of punctuation. By putting a period at the end of a sentence, I'm saying that that sentence is over. And I can move on to a new sentence. And it's the exact same thing with JavaScript. When I put a semicolon, I'm telling JavaScript I'm done with this statement. Okay, I'm going to move on to the next statement. Okay, so That is how we create a variable. Now, as I mentioned to you before, all we've done here by saying var name equals John, what we've basically done is we've created in memory some box, right? So we have some box. Here's our box. Inside this box, we've gone ahead and we put John. And then we've referenced this through name. Okay, so that's what we've got here. We've got this string called John, and this string is being referenced through the concept of the variable name. Now, if I want to change this, if I want to make this Cindy, the thing is that it doesn't make sense for me to create a new variable called name and have this point to here and change this to say Cindy. Okay, so we don't need to create a new variable called name. This variable over here, we can continue to use. The only thing we need to change is the content inside of this variable. So in other words, what I'm trying to say to you is the first time that you create a variable, you need to declare it with this var keyword. Okay, you need to do that the first time. However, after you've declared the variable, after declaring the variable, now it's fine for us to change the data by saying, actually, you know what? Name is actually going to be Cindy, not John. And then maybe after I go ahead and print this out, so I'm going to console.log name over here, I can go ahead and change this again and say, you know what? I don't even want it to be Cindy. I want it to be the number 45. Now, I know that this is very strange, and you would never do something like this normally, but I just want to show you that this is absolutely possible. We can continue to reuse the same variable that we created at first, okay? It's now Cindy, and now it's the number 45. If I go ahead and I actually run this, you can see the results of this, okay? So different types of data are capable of being stored in the exact same variable. The fact that I initially gave this the string data type does not mean that for the rest of this program, it has to keep being a string. Okay, I'm free to put anything I want in that variable. And I do not need to do this every single time I'm changing the data in that variable. Okay, so I hope that's clear. The thing that you're going to see with a lot of variables is that we can really go ahead and make these as complex or as simple as we want, right? So if I had something like temperature over here, and I gave this 15, let's say maybe this is Celsius, so 15 degrees Celsius. And now I want to modify this. What I want to do is I want to take temperature, which is 15 degrees Celsius. I want to multiply it by 2, and then I want to add the number 15 onto it again. Let's say I wanted to do something like that. I could do this. I could say temperature is now equal to 15 plus, and then I could inside here go and say temperature times 2. Okay, and so what I've done here is I've changed this variable's data from being 15 to 15 plus temperature times 2. Okay, now sometimes when you look at something like this, you might think to yourself, you know, what is being executed first? Is it doing 15 plus temperature? And then once it calculates this result, it's multiplying it by 2? Or is it doing temperature multiplied by 2, and then is it adding it to 15? And the answer is that it follows the exact same rules that you learned in school, where the same kind of rules that we follow when we're evaluating equations in math, okay? In other words, things like multiplication take priority over things like addition or subtraction, okay? But even remembering this, sometimes it's nice for us to be really explicit, for us to be super clear and say exactly what should be executed first. So what we can do is I can wrap this in parentheses or brackets. And what I've done over here is I've said to JavaScript, no matter what, you must do this operation together. The things inside the brackets here, these need to be done together. So there's no confusion now. No one is going to be confused that 15 is being added to temperature. It's clear that temperature is being multiplied by 2, and then that answer is being added to the number 15 here. And brackets are very powerful because they are going to control the order of what gets executed. If I was to go ahead and do this, now what we're saying is, I want you to take 15, add it to temperature, which is 15. So this is going to give us 30. And then take the number 30 and multiply it by 2. This gives us 60. 30 by 2 is 60. So that is the effect that brackets give to us. Okay? Now, the problem that we've had so far, the problem is that we've not really been able to make any interesting decisions. Let's say, for example, that I wanted to say something like this. I want to determine whether or not I want to go out and play. So I want to say something like, if temperature is, warmer than 15 degrees Celsius, then I want to go out and play. But if it's less than 15 degrees Celsius, maybe I don't want to go out and play. Until now, we haven't been working with anything that allows us to make these kinds of decisions. And the most important thing that you're going to find in programming is the ability for us to make these kinds of decisions, right? Either go one route or go another. This way of branching and making decisions can be accomplished using this idea of if statements, okay? And so the way that we can write this is actually very, very English looking, right? It's very easy for us to write. I want to say that if the temperature is warmer, if it's more than 15 degrees, then I want to go out and play. And the way I can do that is by literally just translating that English sentence into code. I can say that if the temperature is warmer, meaning greater than 15 degrees Celsius, then what do I want to do? Well, I want to go out and play. I'm going to say go out and play. So if we break this down for a moment, there's a lot of stuff that's going to look familiar. First, we have our console.log. This is familiar to us. We can print something like go out and play. However, we are only printing this out if this condition here is true. So if you will recall, we have this idea of Booleans. And with a Boolean, I can do things like this. I can say, does 45 equal 45? Does 45 equal 30? Is 45 greater than 30 or 40? Is 45 less than 40? So you can see here how using these operators, these comparison operators, I can compare two values. Make sure not to confuse 45 equals 30. When you are comparing, there's two equals, okay? There's not one, it's two. So we can use these to get a Boolean value back. And a Boolean, right, is just a true or a false. So either this statement is going to give us back a truth or a false about it. And the same thing applies right over here. Is 15 greater than 15, right? So in this case, 15 degrees is not greater than 15 degrees. So this is not going to print out. And so if I go ahead and run this, we don't see anything. However, if I make one small change, if I do this, what I'm saying now is if the temperature is greater than or equal to 15, go out and play. And temperature is greater than or equal to 15. It is equal to 15, so it says go out and play. Now, if I was to go ahead and delete this, right? So say something like if temperature is greater than 15, go out and play. This is not going to print out, right? We don't see anything. However, we are able to handle scenarios where the inverse is the case. So in other words, if it's not greater than 15, we can have something that we're going to do instead. And so you can think of this else as being just like saying instead. So if this is false, then just do whatever is inside here. And so over here, I can say something like study programming, okay? And in this case, it's going to go ahead and show us study programming, okay? So the things that you need to really understand about this is the first thing that's always going to happen is the thing inside these parentheses of this if statement. This is first going to get checked. Once this Boolean expression is checked, is temperature greater than 15? JavaScript is either going to give us back a true or a false. In this case, because temperature is not greater than 15, it gives us back false. If an if statement has false inside of it, then the code inside of these curly brackets here, this code is never going to be run. Okay? So in other words, anything you see inside of these curly parentheses, these curly brackets here, this is never going to get executed if this is false here. And I can show that to you because if I simply run this, you'll see that nothing actually shows up. If the thing that goes in here is true, however, then that's different. Now it will show up. And so what we're doing is we are simply just putting a Boolean condition inside here. We're putting some kind of comparison. We're taking two things and we're comparing them with this. And the result of this operation is going to be a true or a false. And because it's false, JavaScript will skip all of the stuff in these curly brackets and it'll move on to the else. And for the else, it'll go ahead and automatically print out anything it sees inside of here. Okay? So this is the idea behind if statements. And we can make our if statements much more complicated than you would initially imagine. Okay? So here's a very simple way that we can make it a little bit more complicated. I'm going to say var age is equal to 40. I'm also going to make another variable, and I'm going to call it is citizen or PR for permanent residency, and I'll say true. And what I'm going to say here is if the person's age, if their age is greater than or equal to 18 years old. Okay, if this is the case. And I also want to check if their citizenship, okay, is equal to being true. They are a citizen or they have PR. Let's presume this means of Canada. Okay, so they are a citizen or PR. We can say of Canada. If this is true, then what I want to do is I want to go ahead and say go vote. Okay, so you can go ahead and you can vote. In order to vote, these two things need to be true. Age must be greater than or equal to 18, but also the citizenship or permanent residency, the PR of that person should be of Canada if they want to vote in Canada. Now, actually, I don't think people with permanent residency can vote. I could be wrong. I don't think this is possible. So, you know, let's just pretend that that's possible. Okay, then if that's the case, then go vote is going to show up. Okay, so we actually go ahead and we run this. It says go vote. Now, the important thing that you have to keep in mind here is we have this word here called and. There's two ampersands. This means and. And what it's saying here is that this condition, this must be true. We need this to be true. And we also need this comparison here to be true. This has to be true. And if both of them are true, then we can go inside of here. So let's go ahead and make this false. I'm going to make the age of this person 4 years old. And if I go ahead and I run this, it isn't going to print anything out. Now, of course, I could do something like this. I could go ahead and put an else and say, you are too young, right? And it'll show that. However, the thing about this is the and, this double ampersand, this and operator is the reason that this will not print out. They both have to be true, and this is going to be false. 4 is not greater than or equal to 18. If I want to say, however, that just one of these conditions needs to be true, not both of them, I can, instead of using this and operator, this thing to say both of them need to be true, and, instead of doing and, which is this, I can go ahead and put two pipes, which is another way of just saying or. And what or means with this thing here being or, what that means is as long as one of these conditions is true, then this entire thing will be true, as long as just one of them is true. So in this case over here, even though this one is false, right? 4 is not greater than 18. It's false. But because it's true that we are a citizen of Canada, because this is true, meaning true equals true, because this is going to be true, this or only cares about if one of these is true. And as long as one of them is true, or is going to convert this to just being true. The whole thing is going to be true, which means go vote is going to be printed. Okay? So if we test this out, it says go vote. So the point I'm trying to show is that if statements can become much more complicated. Now it's easy for you to screw this up if you type the incorrect syntax. When I say syntax, I mean the grammar of the language. So if we take a look here, I have something similar. And I'm saying if the citizenship is American or, you know, South Korea, so South Korean or Germany, if that is the citizenship, then I'm going to print go vote. Now, this looks like it makes sense. If your citizenship is American or South Korean or German, if any of those apply to be true, if any of these are true, go vote will print out. But the problem is that we have a bug in our code. And does anyone know what the issue with this is? This is incorrect syntax, and the reason it's incorrect syntax is because every single time we do an or, alternatively, every single time we do an and, anytime we do something like this, we have to repeat the full statement. In other words, we have to do this. If citizenship is American, or citizenship is South Korea, or citizenship is German, okay, we have to rewrite this in order for JavaScript to be okay with what we've done. Now, this is a little bit long, right? It's a little bit difficult to read. So what you can do with JavaScript is you can add some extra space by pressing the Enter key to make it easier to read. JavaScript will not care about that. So I can go ahead and I can do this. Okay, and so what we're trying to do here is we're simply just trying to make it a little bit easier for people to read. And so now what we're saying here is if your citizenship is any of these things, then go vote. Okay, and we can say else, we can say console.log, I don't know, then just go home. So if we go ahead and we run this, it's going to tell us to go home. And it says to go home because we are Canadian, and Canadian is not matching any of these here. But if I'm from South Korea and I go ahead and I say South Korea like this, that's different now. Because now this one is going to be true. And because one of them is true, as I mentioned, as soon as one of them is true, this entire thing becomes true. And therefore, the content is printed out. Okay? Now, if you want to give this a try yourself, and I suggest you do give it a try, then what you should try and do is determine if a number is odd or even. You can give this a try. And what should happen is if I have a number like var num equals 45, then my program should tell me if this is odd or if it's even. And in order for you to figure out if a number is odd or even, you can do a really simple trick. What you can do is you can just think back to math and the fact that any number that I take, right? So if I take the number 42 or the number 12, these are even numbers, right? If I was to divide 12 by 2, right? I get the number 6. And the remainder is 0. There is no remainder, right? There's no remainder because this is an even number. In other words, the number 2 will evenly divide into 12 without us having any remainder. So what we can say here is that any number which I divide by 2 and I don't get a remainder, then I can say it's even. And if I do get a remainder, like remainder 1, then it means it's odd. And this is a way that I can determine whether something is odd or even. There is a very useful operator, which is called the modulus operator. And the modulus operator is simply just an operator that does the same thing as division does, except it gives us back the remainder. And so this percent sign over here, this is what we call the mod operator. And when I do something like this, it tells me that there's no remainder. On the other hand, if I go ahead and I do something like this, 13 mod 2, then it turns out that the remainder is 1. So based on this logic, we can go ahead and figure out whether something is even or whether something is odd. Because in this case, it has to be even. It has to be even because the number 12 has no remainder when it's divided. And the number 13 has to be odd because it does have a remainder when it's divided. Okay, so spend 20 seconds and go ahead and just try and write this out, while I check chat to see if anyone has questions. And if you didn't write on chat, but you still have questions, feel free to ask. Thanks to Jamie Samuel for helping out in chat. Definitely for people who know more, if you can help out in chat, that is super appreciated. For Alex, who was wondering about the 2 ands, so yeah, the only reason that we have to put 2 ands or 2 ors in JavaScript to express and or, the reason we have to do that is because simply putting 1 and, simply putting 1 or has a totally separate meaning in JavaScript. So this is also something, it's something we're not talking about right now, but it's something else. It's something that means something different. And so that's why we cannot just use a single and or a single pipe. Okay, so if you've given it a try now, and even if you haven't, we can go ahead and we can write this out, right? So the first thing I'm going to do is I'm just going to go ahead and give myself a number, in this case, the number 10. And now I want to go ahead and I want to write an if statement to determine if something is even or something is odd. Now, this is usually what I do not like to see in your code, okay? If I was marking one of your labs and I saw something like this, okay? Something that checks if the number divided by 2, mod 2, which gives us the remainder, if the remainder is 0, then console.log even. Okay, so far this is fine. But what some of you may do, especially if you're new to JavaScript or programming in general, is you might just copy this if statement and now go ahead and check the opposite, okay? So basically we want to check here if it's not 0, right? And first, I'll just mention one thing about this, okay? And then I'll go and tell you what I don't like. So inside of my code here, I have some checks that I'm doing. I'm saying if num mod 2 equals 0, right? And so we're doing a comparison because the number 10 mod by 2 is going to give us 0. And if we do 0 equals 0, we're going to get true. And that's why right now this if statement is going to print even. Okay, so that's fine. But what if I wanted to check here and just say if num mod 2 does not equal 0, right? So if I want to do that, I can actually just type the following. I can say something like num mod 2, in this case my num is 10, num mod 2 equals 0. So we know this is going to be true, okay? But alternatively, I can say does not equal. And so notice here that I have equals to say, does the thing on the left equal the thing on the right when I do comparisons? That's why I have 2 equals, because I'm comparing 2 things, right? But if I want to go ahead and say not does the thing on the left equal the thing on the right, but I want to say does the thing on the left not equal the thing on the right, I can go ahead and put this exclamation point. And therefore, it's going to say 10 mod 2 does not equal 0. That's false. And it's false because in reality, 10 mod 2 does equal 0, right? And so that's why it's saying, no, that's false. It does equal 0. But this is how I can express that something does not equal something else. And if you're wondering about that exclamation point, what the exclamation point is doing is it's simply flipping an operation. And what I mean by flipping an operation is, let's say I have something like this. I'm going to say var correct equals true. And now I go ahead and I say correct, but I put an exclamation point. You can see that all it did was took true and it flipped it. So now it's false, okay? And so similarly over here, what I'm doing here is I'm saying if this thing over here is equal to this thing over here. And if I put this exclamation point, then all I'm doing is I'm saying the opposite. Not equals, but if it does not equal 0. Okay, so that is the thing that you should understand over here. And this can be very powerful when we're trying to make programs that are easier for us to read. Okay, because if I have something over here where I do something like var citizen equals true, and then I go ahead and I say something like if citizen is true, okay, if citizen is true, then console.log you are a citizen. Okay, so if I have something like this, it prints out you are a citizen. But what I could do is, if I could just do this, I could say if, and over here, I say not citizen is true. And what I'm saying over here is essentially the same thing as if I say over here, if citizen equals false. Okay, now when you do labs and stuff like that, you're going to practice with this. This might seem kind of weird in your head if you've never seen this before. But the idea here is that we're just trying to understand the logic behind these operators, right? So if citizen equals true, okay? If citizen equals true, we're just saying if this citizen variable, if that variable is equal to true, then I want you to print this out. And if I flip this by saying if not a citizen is equal true, it's the same as me saying citizen is equal to false. Okay, now going back to here, I can say if num mod 2 does not equal 0. If num mod 2 does not equal 0, then go ahead and show odd. Okay, so if we go ahead and we run this program over here, it shows even, which makes sense. 10 is even. If I change it to 11, it shows odd. Now this program works absolutely fine. It works fine. However, the code is very verbose. And this is what I was talking about when I said, when I see your labs, I want to try and I want you to strive to make your code as concise as possible. Because in what way could I change this so that it's less verbose? How could I shorten this to be easier to read? Well, if you think about it, a number is either even or odd. It's a binary operation. In other words, if it's not even, it has to be odd. If it's not odd, it has to be even. So I could go ahead and just delete all of this and instead say else console.log, and now I could say something like this. And the result is the exact same program, but the code is easier to read. And this is a common theme you're going to see in this course. Oftentimes, we're going to see things that work, but are not good code. And the idea here is that even if a program works, if it's difficult for us to read, if it's difficult for us to understand, then it's not a great program, okay? Now, the thing about this is that we're saying here if and else, but there's a lot of scenarios where just having one else scenario isn't sufficient. I want to maybe have a whole bunch of different else scenarios. So I can say, if this is true, if this is true, go ahead and print this out. But otherwise, if this other thing is true, do this. Otherwise, if this other thing is true, do this. And finally, if all of them are false, then go ahead and just print this other thing out. Okay, so we can make our conditional logic slightly more complicated, slightly more interesting. And the way we can do that is by using else if. Okay, and so if I change this, you can see here that the logic is similar. Okay, so this program over here, a student has a grade of 85%. And right up until here, this is probably familiar for you, right? Because what we're saying here is that if their grade is greater than or equal to 90, I want you to print this out. Now, we both know that 85 is not greater than 90, which means this is not going to print out. And so I want to have an alternative, something else to check if this is false. If and only if this gives me false, then I want to try something else. So what I can do is I can write else if. And in this else if over here, I can check another condition. In this case, is it true that 85 is greater than or equal to 80? And it is, which means this will print out. And I could, in theory, have another else if. Now, if you had to go and actually map the execution of this program, so if I gave you on a quiz, which I probably will next week, if I gave you something kind of like this, and I said to you that I want you to, explain to me the sequence, the steps of how this program is executing, you should be able to look at this and say what, how the computer is understanding this program. Okay, and so what you should do if you're looking at this program over here is you're first going to look at this if statement, and you're going to say, is 85 greater than or equal to 90? Well, we know that this is false. Okay, so this is going to be false. And because this is false, what JavaScript will do is it's going to jump to this next else if, and it's going to skip this entirely. Okay, so this is never going to get run. It's going to skip to this next else if, and it's going to check. And this is going to be true. And because this is true, it's going to go ahead and it's going to print out this code over here. Now, if you look at the next else if, this is also true. It's true that the grade is greater than or equal to 70. But the thing is, once JavaScript finds one case, which is true, as soon as it finds one true case, what JavaScript is going to do, as soon as it prints out the word great, it's going to come out of this entire thing here. So all of this stuff here, JavaScript is going to hop out of it because it found something that was true. So it's never going to execute this code here, okay? And then it's going to see this line of code here, and it's going to go ahead and execute it, okay? So it's really important that when you see these programs in your head, you're able to understand what is happening before you actually run the program. It's important because on our quizzes and on our tests, I'm going to be asking you to explain to me the steps for how JavaScript is actually executing a program. So you can see here how it prints out great, and then it jumps out. This whole thing is finished. It jumps out and it prints this final console.log. Okay. Now, of course, I can always have at the very, very end, I can have one final else. And this one final else is kind of like the default case. It's another way of saying if all of these things fail, if all of them fail, then just do this last thing over here. And this last thing over here can say something like all cases failed. And what would be an example of that? Well, an example of that would be if I said something like 4,000, or actually no, 4,000 is greater than or equal to 90, right? So if I put something that was less than 70, so let's say I put the grade 3. If I go ahead and run this, it's going to say all cases failed because every single one of these ended up being false. And because they're all false, automatically this final else is going to be executed. Okay, so hopefully that makes sense. I don't know if anyone has any questions about if statements and else statements and this kind of logic, feel free to ask. Okay, so the thing about our code here is our code is starting to get to a point where we're really repeating ourselves. And if you take a look at something like this, this is a really common piece of code that you might see. It's a number, like the number 0. And what we're doing here is every single line of code is just adding 1 to that variable. Okay, so if you go ahead and you take a look at this, we're saying change the value of this variable so that this variable equals whatever this is. So your final grade is 0 plus 1, right? So this is going to 0 plus 1. This is going to be the same as this, right? So your final grade is now going to equal 1. And then we're going to do this again. So now your final grade is equal to 2. And 3, 4, 5, 6, 7, 8, 9, 10. Your final grade is now equal to 10. So you can see here how it's printing out 10. Now, the problem with this code over here is that we're doing the exact same operation, over and over and over again. And the problem with this is that, again, when I see your code, I want you to try as much as you can to write code that isn't looking like this, right? A lot of the time you're going to see in programming that your code works, but even though it works, it's difficult to read. And when we start getting into projects where we have tons and tons and tons of code in our projects, even if your code works, if it's difficult for your other classmates to understand what you're doing, then your code is pretty meaningless. The key that you need to understand is that programming is for humans, okay? Because eventually all of this is going to get converted to zeros and ones that your computer will understand. But for us as humans, this is why we use programming languages like JavaScript, so that we as humans can understand this. And if your code is so difficult to read that even a human can't understand it, then we're not doing a good job as programmers, okay? And so we have a solution to this problem, because the solution of what we want to say is we want to tell this variable here, your final grade. We want to say, hey, keep going and keep going for 10 times. I want you to keep adding 1 over and over to yourself 10 times. And once you hit 10 times, go ahead and stop, okay? So we want to say something like that. And JavaScript and most programming languages do offer a way for us to do this. And what they do is they basically say to us, I want to go ahead and I want to loop your final grade. I want your final grade as long as it's less than the number 10. Okay, so as long as your final grade is not 10, as long as it's less than 10, what I want you to do is I want you to take your final grade and I want you to add 1 to it. So this is what I want to say. I want to say, as long as it's less than 10, keep adding the number 1 to this variable. And once this variable is greater than 10, okay, greater than or equal to 10, as soon as this is false, I want you to stop doing this operation here. I want you to stop adding 1. That is what we want to do. And the way we accomplish this is by using a loop, which is available in most programming languages. And JavaScript is no exception. So we can go ahead here and I can say the following. I can say, while this condition here is true, meaning as long as your final grade is less than 10, okay? As long as this is true, then I want you to do the code inside here. And so then I can go here, I'll add some curly brackets and I'll pop this in, because anytime, just like an if statement, we need to add these curly braces when we want to specify some code that starts and ends. This here, this code exists inside of this statement. Okay, so this is one logical chunk over here. You saw this with the if statements as well, where I have some Boolean condition, like if true equals to something, and then if that ended up being the case, we do everything that's inside of these curly brackets. This is really similar to an if statement. but instead of if, we change it to while. And what this allows us to do is it allows us to do the thing inside here over and over and over again, as long as this is true. So let's go ahead and run this exact same thing. So I'm going to go here, and I'm going to say console.log your final grade. And when I print this out, you're going to see the exact same thing shows up. It still shows 10. But even though it shows 10, this is much easier to read than what we had before, because what we had before was this code over here. Now, it may be difficult for you to visualize what is going on when you see this here. Okay? It might be difficult for you to visualize. If you are having troubles visualizing this code, I suggest you go to Google and you type Python tutor, not tutorial, Python tutor. You should type this, and you should go to this first link over here, pythontutor.com, and then you should choose JavaScript tutor. Okay, this one over here, JavaScript tutor. You should then go ahead and take your code. Here is the code. I'll remove this comment over here. So you should take this code, and you should paste it inside of this window. And then you can click Visualize Execution. According to this program here, it takes 23 steps, 23 stages for JavaScript to calculate this final grade over here. For this program to finish, it takes 23 steps. And so if you take a look at this, everything I said should make sense. Remember that we're starting by saying your final grade is 0. So this line of code hasn't executed yet. Okay, we haven't executed it yet. Once this line of code runs, now we have a variable that exists inside our memory called your final grade with a value of 0. In memory, we have this variable. It has the value 0. Next, we have this while loop. And the while loop is going to have to do this comparison. Is 0 less than 10? So I'm going to click Next. And you'll see that now we've gone inside the while loop. We've gone inside it because that's true. 0 is less than 10. So what we're going to do now is we're going to take your final grade plus 1. Okay, your final grade is currently 0. So we're going to go 0 plus 1. 0 plus 1 is going to give us 1. And 1 is going to be assigned or stored in your final grade. So now you can see that your final grade has gone up. It is now 1. We'll do this again. And if you notice, every single time we do the loop, you'll see this number here keeps incrementing by 1. And it keeps going on because every single time that Boolean condition is still true. In other words, 7 is still less than 10. 8 is still less than 10. 9 is also still less than 10. But finally, when this variable, your final grade, when it equals 10, this is no longer going to be true. It's going to be false. Right? 10 is not less than 10. And so finally, when this while loop becomes false, we're going to break out of the loop, and we're going to enter this final print statement. We print out 10, and you can see the output over here. So I highly encourage you to use this program, pythontutor.com/JavaScript. Use this program if you need help visualizing what your code is doing. Okay, I highly, highly encourage that. The last thing that I want to mention before we take a break for a moment and switch gears, the last thing that I want to mention is that when you are working with loops, usually you want to loop over data. Okay, you usually don't want to loop over something like a single number. Okay, and so as a simple example over here, if I go back over here, it's possible that we have the final grades of 5 different students. So our students here, we could have something like, Octavio, and we could have John and Stephen and a whole bunch of people. So we have some students over here. And let's say that their final grades are 90, 91, and I don't know, 89, something like that, okay? Just random numbers that I picked. And I'm gonna go ahead and call this final grades. You'll notice that we've put 3 numbers here, and we've wrapped this in these square brackets over here. So We're going to get into this way more in future lectures, but it's important that you have an idea of what this is, okay? So the term for this is called an array, but in reality, most people like to just call it a list. And the idea here is if I have several different numbers, like 90 and 91 and 92, instead of me creating 3 different variables for each student, because I could absolutely do this, right? I could say final grades 2 and final grades 3. I can express all of this in one single variable. And in order to do that, I need to use this concept of a list. And so you can see here that by using these square brackets, I've put these square brackets here, I can go ahead and put as many pieces of data as I want inside of this list, okay? That means that I no longer have to define each of these separately. I can put all of them inside of a list. And the interesting thing about this list is I can now loop over it if I want to. So there are 3 items in this list, right? There are 3 items in this list. And I can go ahead and say something like this. I can say something like, while 0 is less than 3, then what I want you to do is I want you to console.log list of grades, okay? So if I do something like this, if I print out list of grades this way, we're gonna see the following inside of our terminal. And you can see right now that it's actually going on forever. And the reason this is going on forever and it's never stopping, it just keeps printing out this list, is because I never created an opportunity for this while loop to break. Okay, so if you look at this while loop, this is forever gonna be true, right? 0 is always gonna be less than 3. And so because of that, it's gonna keep printing this out over and over and over and over forever. It's the same thing as if I did this, while true, go ahead and print this out. This is gonna be true forever. So what we need to do is we need to have a way of saying that when you reach the end of this list, break out of this loop. Okay, so once we reach the end of this list, I want you to stop printing out the numbers over and over and over, okay? And here's how we can do that using things we know. I'm gonna create another variable here, and I'm gonna call it I, but you can call it whatever you want, okay? So var I, and I'm gonna set it equal to 0, okay? And what I'm gonna do is I'm gonna say, as long as I is less than 3, okay, as long as I is less than 3, then I want you to print out this list. And not only that, I want you to print out this list, and then I want you to add +1 to I. So I want you to do this. What this is gonna do is we're gonna create the variable I, and we're setting it equal to 0. 0 is less than 3. That is true. So we're gonna print out this entire list, just like we did here, 90, 91, 92. We're gonna print out that list. Then we're gonna add the number 1 to I. So now I is gonna be equal to 1. We're gonna print out the list again. I is gonna be equal to 2. We print out the list again, and finally now, I is gonna be equal to 3. And once this variable here, I, once this variable equals 3, this is no longer gonna be true. And because it's no longer true, we're gonna break out of the loop. And so you can see here how if I run this program, it only prints out 3 times. It prints this list of grades 3 times, and then once I is equal to 3, this is no longer true, okay? Now, it's great that we can print out this list, but what if we want to just print out individual items in the list rather than the entire list itself? Well, the way we can do that is by going inside of this list, okay? We can go inside of this list. And the way we can do that is very simple. If you take a look over here, I'm gonna create a list, which I'm gonna call LST, and I'm gonna give it John and Stephen. Okay, so we have 2 people in this list. If I was to simply just print out this list, it gives me the entire list back, okay? However, if I just wanna get one single individual person from this list, what I can do is I can say the name of this list, LST, that's the variable name. And in square brackets, I can put a number that represents the position of that individual in the list, okay? Usually in life, when we're counting, we usually count from 1, so 1, 2, 3, 4, 5. But usually in programming, we start with the number 0. Okay, so this is the 0th position in the list, the 0th item in the list. It sounds weird. Normally, we'd say this is the first item, the second item. But when we're counting positions of things in a list, we start at 0. So John is at position 0 in the list, and Stephen is at position 1 in the list. And so I can simply say, give me whoever is at position 0 in the list. Or inside this list, give me the person that is inside position 1. And that'll give me Stephen. So you have to put a number in here, and that number represents the location of the item in the list, okay? So if we go back to here, if I change this very slightly, so instead of printing out list of grades, I print out list of grades of 0, it's now gonna print 90, 90, 90, because this is the 0th position. And because that's the 0th position, it's gonna give me the first item, which is 90. So 0, 1, and 2, okay? If I go ahead and of course change this to 2, it's gonna give me 92. And it's gonna give me 92 because you can see here, 2 matches with 2. So if I wanted to print all of the items, I could simply change this to I. And I can change it to I because remember that this variable I here starts at 0. And because it starts at 0, 90 is the first item that I points to, 0. It's the same thing as me putting 0 here. But because it's I, every single time I is increased by 1, I can go back over here and list of grades is now automatically going to point to 2. So it's going to start at 0, then it's going to go to 1, and then it's going to go to 2. And it does this automatically for me because I use the variable I. Okay, so if I was to go ahead and print this out, it shows me 90, 91, 92. If this is your first time ever looking at a loop, this might look strange to you, but I assure you that you will get used to seeing this kind of thing. So we have here a list, okay, also known as an array. This is one thing that we have, and we can loop through the items in that list by using a loop. And in this case, we are using what is known as a while loop, okay? Now, I know I talked a lot over there, so I want to first just confirm if anyone has any questions. I will check the chat for a moment. Okay. Linda is mentioning about triple equals, which is great. We're going to be getting into that a bit later, and that's awesome that people are already talking about it. So yes, we will be getting to that. And since it seems like there's no questions, I will continue on. Okay. So right now we've got all of the major basic building blocks we need to be able to make programs. Okay, so with everything that we've discussed so far, we have all of the fundamental things we need to make a program. There is only one last thing that is missing in our ability to make programs. So we just have one final thing which is missing. And that one final thing which is missing is the fact that currently, as I told you, we still have a lot of code that is written like this, okay? And so if you look at these kind of statements, you know, this is a fairly normal set of code, but I might want to use these 4 lines of code in some other part of my program. Let's say that this here is my introduction. So this is an introduction about, you know, who I am. If that's the case, let's say, you know, 500 lines down. So, you know, I have a really long program, and later on I want to reuse this. I'm going to have to keep pasting this over and over and over every single time I might want to introduce myself. And so you're going to see this everywhere in your code. And this is really, really problematic because it makes our code really verbose and difficult to read, okay? And so the thing that we're gonna do to solve this is we're gonna use this concept of a function. And a function is a way that we can, it's a really simple concept actually. It's just a way of saying, instead of repeating this code over and over and over, I wanna put this code into some procedure that I can call whenever I want, that I can use whenever I want. And I don't have to rewrite this every single time. And sometimes on the internet, people make functions seem more complicated than they really are, but it's actually a super simple concept. This is all you have to do. The first thing you're gonna do is you're gonna wrap all of this code inside of curly brackets like this. Okay, so that's the first step. That's step one. The second step is you're gonna go and write the word function. Okay, so that's step two. And the final step that you're gonna do is you're gonna give your function a name. So I'm gonna call it introduction. Okay, finally, add these parentheses, opening and closing, after you give it a name. So you need to give it a name, give these opening and closing parentheses, okay? Write the word function and have your opening and closing brackets, okay? Once you have this, that's it. That's all you have to do. And now for the rest of your entire program, anytime you want to print this out, you can simply just call that function. You can go and say, hey, introduction, I want you to run all the code you have inside of you. And so you have to add, you cannot forget to add these round parentheses, okay? So you have to add them. And if I go ahead now and run this, it's gonna print it out, which is great because now I can go ahead and use it as many times as I want. So I can go ahead and print this, and it's gonna print it 4 times for me. And this is a really great strategy. It's a great strategy because we don't have to repeat this code over and over in our program, okay? And that is all there is to functions, okay? Now, I wanna mention something to everybody who's listening to this lecture, which is I have hundreds and hundreds of slides that I'm gonna provide you that basically rehash and repeat everything I talked about in this lecture, okay? So if you forget anything that I mentioned, you can look at the slides, and usually I'm gonna post the slides before class, so you'll be able to, you know, go dig deeper into these concepts, okay? But so you don't have to remember everything that I talked about today. That would be impossible. But the idea of a function really is simply this. I have some code and I wanna use it in a whole bunch of different places. I can just wrap it inside a function like this, and then I can call that function whenever I want to use that code, okay? And the thing about this function here is that this function is very static. And what I mean by that is, unfortunately, it's going to print the same thing every single time. So in this case over here, it's going to say the word hello every single time. But what we might want to do is we might want to send some information into this function. Information from the outside world here, we might want to send some data into this function, which the function can use, okay? So let me give you an example of some sort of information. I'm gonna go here and I'm gonna put the word greeting, okay? So I'm gonna put the word greeting over here. And over here, I'm gonna change this word hello. Okay, I don't want this word hello to be here. So I'm gonna delete it. And instead, I'm simply just gonna go ahead and say greeting. Okay, so I've put this variable here plus this string. This here is what we call a function parameter. And a function parameter is basically a placeholder variable where I can take something and pass it in. So I can go ahead and I can say something like, I can say bonjour over here. I can take this and I'm gonna put this into this greeting variable over here. And then inside of this function here, I can go ahead and use it, okay? Now, the actual names that you give for these variables doesn't actually matter. So I can go ahead and call it whatever I want, right? So I can go ahead and call it G1 if I want. But the important thing is that the name you give it should match. The name here should match the name that you use inside here. These should match. So what we've done here is we've passed in bonjour as a greeting. And I'm gonna go ahead and also put hello. And I'm also gonna go ahead and put, I don't know, I'm running out of languages, so whatever other kinds of greetings. I'm going to go ahead and put greeting 3 over here, and maybe we have another greeting over here. And so what we can do with this is if we print it out, we've now got a function that's kind of smart, because you can see here that it prints in French, and then it prints in English, and then it goes ahead and prints in Japanese, right? So we are able to pass different values into our functions, and these functions become more flexible because of that. And there's no limit to how many of these values we can put into these functions. We can go ahead and make things really, really complicated if we want to. So I can go ahead and say something like language over here. And what I can do now is pass something like French. And I'll delete these 2 over here. I'm going to pass over here English. Okay, so I'm passing a language. Now make sure that you understand what is going on here, right? We have a function, and this function is taking 2 parameters, right? So this one over here, bonjour, that's going to greeting. And French is going inside of language. Now currently, even though we're sending French into this language parameter, it's not actually being used, right? We're not using this yet. And that's fine. Technically, you don't have to actually use the things you send into functions. So if I run this again, if I go ahead and run this, it's going to run exactly the same. Even though I sent these new parameters, French and English, into this language variable, you'll notice that in this function, we never use that language variable. So because we never use it, it's never actually, it doesn't make a difference to our program. But let's say we decided to use it over here. So I can go ahead and say something like this. I'll say something like, if language is equal to English, then I can go ahead and say something like console.log, my language is English, right? And then after that, I can go ahead and say something like, else, if the language is not English, let's say the language is French, then I can go ahead and put some new console log for that. So the same concepts that you learned regarding if statements and stuff like that, you can put those inside of your functions, and things are going to work absolutely fine. And of course, we can put an else at the very end to say something like, if it's not English and if it's not French, then I'm simply going to print out my language is something else. Okay, so now I'm going to go ahead and delete these, so it's a little bit easier for us to read. And you can see here that we have a function, and this function has inside of it an if else conditional statement in here, right? So we're checking, is the language equal to English, right? And if the language is equal to English, then we can go ahead and print, whatever we want. And if it's French, we can print something else, okay? And so if I actually run this now, I can go ahead and run this, and it says my language is French, because this first one over here, French, is going to get sent into here, and it's going to print this one over here. And then finally, the second one, my language is English. This one, this word English, gets sent into here. Functions do not need to have the var word added, okay? So it's a special case just for functions. You don't have to put this var keyword. You can simply just do this, okay? And so you will be seeing this idea of functions coming up a lot into our course, okay? And the thing about this function here is it's pretty much perfect, okay? This is pretty much a complete function. There's only one thing that is missing from this function. And the thing that's missing is sometimes with functions, I don't want to necessarily just print out to this console here whatever the result is. So in this case, we're printing out my language is French, my language is English. So let's say I just have this over here. It prints out my language is French. What if instead of printing out my language is French here, what if I just wanted to get this value given back to me? Not in the console, but maybe in a variable. Is that possible? So in other words, can I do something like this? Can I say something like var, I'm putting this in capitals so it's obvious, language given to me. equals this. In other words, can I create a variable? And inside this variable, I save whatever is written over here. And the answer to that is currently no, I can't do that. Because when we say console.log, we are telling JavaScript, take whatever is inside here and send it directly to our terminal, to our console. And sometimes, as I mentioned, we don't want to do that. Instead of sending this to our console, we want to send this into this variable here. So we want to call this function introduction. We give it French. French goes inside here. The language is not English. This is false. This one is true. And we want to give this sentence back to this variable. We don't want to just print it to the console. And the way we can do that in a function is by using this keyword called return. And instead of console.log, if we say return, what the function is going to do is it's going to take this content over here. It's going to take this, and it's going to give it right back to us. Okay, so you see here, it's optional whether you want to use this or not, the curly braces, there are parentheses, but we take this, and it's going to be sent to this variable over here. This variable is going to receive my language is French. And so if we test this out now, I'm going to say console.log, and then I'm going to say inside here, language given to me. And when I run this, you can see it says my language is French. And if I didn't do this, if I didn't put this return, and I said console.log, then this would no longer work. Okay, so if I do this, and I run this program, you can see that it does print to the console. It does print my language is French over here. But this one ended up printing undefined. Okay, so this didn't work. And if I just console log this out for a moment, you can see that this, my language is French. This is printing from the console because of this. But this one over here, if I just try and make this explicit for you, so I'm going to say the value of this variable is, and if we take a look at what this variable gives us back, it says the value of this variable is undefined. And of course, it's going to be undefined because inside of this else if over here, we just said, take it and shoot it right over to the console here. Just shoot it in the terminal, print it in the terminal. We never said we want to return it into this variable here. So it never got saved in the variable. We can actually do both if we wanted to. So this is totally valid to do this. You can say console.log, my language is French, and also go ahead and return my language is French. This is absolutely fine. What we're going to do here is we're going to first print my language is French. And then after we print that out, we're going to take this string and return it to this variable over here. And if I go ahead and I console.log language given to me, you're going to see printed twice. This gets printed twice. Okay, because the first time was from here, and the second time is when we return this into this variable and print it out. Okay, so I'm hoping that that makes sense to you. I want you to try something out on your own, just to see if the things that I've talked about so far are making sense to you. Okay, so I'm gonna put something on my screen, and I want you to just give it a try and see how you do. Now, the thing about this is this task that I'm giving you over here, this task is going to involve a couple things that you haven't explicitly learned from my lecture, okay? Which means there is going to be a few things that you might actually have to Google in order to successfully complete this task, okay? But nevertheless, I want you to give it a try. And while you're giving it a try, for anyone who's having problems with their Node.js or things like that, you can bring it up with me. And we can figure out a time later on this evening where we can meet to talk about it. And also, if you need to take a short break, you can also take a short break, like a 5-minute break. But give this a try otherwise. Okay, so If you don't have anything to ask me, then go ahead and give that a try. Okay, so I I think there's a feature in Zoom that allows, oh, and there might be a typo. I'll take a look at that. I think there should be a feature in Zoom that allows people to put a show of hands to see like how many people actually have completed this. Is there like a raise hand sort of feature? I think there's something like that. So that we can see like how many people have, oh, actually I think I can just do a poll. I think that's also a thing. Okay, so I just launched a poll, which is anonymous. It's anonymous, so go ahead and answer. Okay, so it seems like the majority of us are still working on this exercise, which is totally fine. So I'm gonna allow you to keep working on this exercise, but before we do that, I need to do a little bit of housekeeping so that we understand what kind of deliverables and things we're gonna need for next week. So I'll end this poll. Okay, so the first thing I want to mention is if you don't already have it, please make an account with Notion. Okay, so this is a platform we're going to be using for a bunch of things. You don't need an account right now, but you will need it eventually in the course. So having an account with Notion, okay, that's the first thing. And I believe that Notion, if you type, I think if you type /students, there's a free version that they have for students. I mean, it's already free, but I believe that if you use the student version, you get even more things for free, I think. So because they do have like a paid version, and I think the student version includes everything that the Personal Pro includes. So make an account with Notion and have that, because we're gonna definitely be using that in this course. Okay, so the next thing I want to do is all the things that we talked about in today's class, I've gotten compiled now into a bunch of notes here. Okay, so these notes here represent things we talked about in today's class, but also stuff that we didn't talk about in today's class. Okay, so things we didn't talk about in today's class, I've still included. Okay, I've still included it in these notes, but you're never going to get tested on things that I haven't actually included. I mean, things I haven't talked about in class. Okay, so you're only going to get tested on things that we have actually talked about. Okay, so if what I'll do right now is I'll go ahead to Slack, and in our Slack, I'm just going to go ahead and post a link to this Notion. So if I go to, I guess I can go to here in announcements. You can see the link is posted right over here. Okay, so once you click this, you should be able to see, if I go ahead and test this right now, you should be able to see all the things that we talked about in today's class, okay? So that's the first thing I want to say. I will also be posting today slides as well as office hour information for all of you, okay? So slides pertaining to today's classes. I don't usually talk about slides during class because I don't like showing slides, but I will provide them for you still if you want them for reference. Okay, so this is the first thing. The second thing is in terms of deliverables for today, or not for today, but for next week. Okay, so for next week, what I would like from you is I would like you to complete the exercise that I just showed you a moment ago. Okay, so complete it. You can put it in some file. So that's the first thing I want. And the second thing is also a really small program in Node, really just a function that will just convert temperatures from Fahrenheit to Celsius. Okay, that's all. And you can look up on Google what the actual formula is from converting from Fahrenheit to Celsius. Okay, you don't have to go from Celsius to Fahrenheit. You can add that if you want, but at least from Fahrenheit to Celsius, okay, for temperatures. So I want you to be able to complete these two programs. Now, the thing that I want to tell you about before class ends today is, let's say that you've completed these two programs. Okay, so you finished these and they're in maybe two different files and you want to submit them to me now. How are you going to submit these programs? Okay, and you know, throughout the course, it's going to depend. Sometimes we're going to use Learning Hub. Sometimes I'll ask you to just send me a direct message on Slack. Okay, but for this week, I want you to use Git as a means for submitting your programs over to me. Okay, so I want you to use Git, and I'm going to briefly go over right now how you can do that. And I'll have a caveat to this, which is if you have problems submitting to Git, let's say you have some issues and it doesn't work out, excuse me, you can just submit it to me directly on Slack. Okay, so you can send me a direct Slack message with your files if you are unable to get Git working. But I really want you to try and get Git working, okay? I really want you to try and submit it using Git. And I'm going to show you right now. We end today at 12:20, so we still got 20 minutes. I want to show you right now exactly how you can go about submitting your programs. Okay, so and I'll share this with you in a moment. Okay, this in-class lab. So remember that we've already installed Git. Okay, that's one of the things that we had to install was Git. So looking at this question, okay, which I'm gonna send it to you all, so don't worry about it if you didn't catch this. So the question is basically just asking for a series of things we need to do, right? Like it's asking for us to make an add movie function. It's asking for us to make a print favorite movies function. It's asking for a few things that we have to do. So really the only thing you have to do for this question is just function by function do what it's asking you to do, but it's going to require looking up a few things. So let's look at I'll start you off with one of them. Okay, I'll start you off with one of them. So one of them is saying that we need to have a add favorite movie function. Okay, and an add favorite movie function takes a parameter which is called movie name. Okay, and what that function is supposed to do is it's supposed to check if the movie we're sending into that function has the word "the" in it. And if it does have the word, sorry, if it doesn't have the word "the" in it, so movies like Harry Potter doesn't have the word "the" in it. If it does not have the word "the" in it, we want to add it to a list that we create called favorite movies. Okay, so it could feel overwhelming if we look at all of that, but if we do it piece by piece, it's not actually going to be super bad. I'm not going to do this for you, but I am going to start you off just so that you have an idea and so that I can demonstrate Git. So I'm going to comment this out right now. In JavaScript, we can write comments like this if we want to comment several lines of code at once. Okay, so I've commented it out, and I'm going to do exactly what it says. So it first says, create a function called add favorite movie. So remember that with functions, you need the curly brackets, you need to have the word function, you need it to have a name. So here's the name, and the opening and closing parentheses. So here's our function. Eventually, we're going to call this function at some point. And when we eventually call this function, it's saying that we have to give it something. We have to give it a movie name, which means that there is a parameter in here which is called movie name. And we are giving to that function some movie name. So for example, I can put inside here Spider-Man, and I can call that, and I can go and make another one here. So I go over here, and I can put another movie. Okay, so we have some movies that we've put inside of here. And remember the way functions work. When you call a function like this, when we try and call the function, we're basically trying to tell the function, hey, I have something to give you. I want you to take this thing I'm giving you and put it inside your code and run it. So over here, we're sending Spider-Man into this function. We're sending the word Spider-Man. It goes into this variable movie name. And now we're going ahead here and we can print out movie name. And this should work absolutely fine. So because we're calling this function twice, if we test it out, it shows us over here Spider-Man and Parasite. Okay, it's a little bit hard to see, but if you can see over here in my terminal, it says Spider-Man and Parasite. Okay. Now, what this is saying here is that if the movie string does not have the word the in it, add it to the favorite movies array. So that means that presumably somewhere we need to have some list. So I can say something called favorite movies. And this is going to be a list. Now notice that this list here, I haven't put any names in it, right? John, Jim, because right now it's empty. I just have an empty list. And at some point, what I'm gonna wanna do is I'm gonna wanna take this movie name and I'm going to want to push it into this list so that eventually Spider-Man is gonna go from here, it's gonna get pushed into here. Okay, that's what's gonna happen. And in the hints for this, I explained the process for how you can go about doing that. So anyways, this is the kind of thing that you wanna have. Okay, if you want, what you can do is you can put both of the programs, the temperature program and this one, in the same file. Or if you want, you can go ahead and create another file, and we'll call this program2.js. And inside program2.js, I can go ahead and write whatever function I want, Celsius to Fahrenheit. And now I can go ahead and write the code for this program over here. Okay, so I have two different programs. Now, I'm gonna show you right now how we can work with Git to make this a deliverable, okay? So essentially, we have two things that we're gonna be working with. The first thing is something called GitHub, okay? So github.com. You're gonna need to make an account if you don't have one with GitHub. So you're gonna have to go to github.com and you're gonna have to make an account. And I have many, many, many GitHub accounts. One of the accounts I tend to use for this course is adanji8, but you can give your account, you know, whatever name you want. The point is that you should make a GitHub account. What you're gonna do with this GitHub service over here, this website, is we are gonna take our code here, this code on our computer, and we're gonna share it with GitHub. Once you share it with GitHub, you can send the link to me and I can see your code on GitHub. Okay, so that is what we're gonna do. We're gonna share it with GitHub. Now, the way that we share our code with GitHub is using a tool called Git. Okay, so I'm gonna open the terminal here where it's nice and big so you can see exactly what I'm doing. Okay, so I'm gonna go to the location of where my code is. And all the commands that I'm typing, all of them are gonna be on the slides that I'm gonna give you today. So you don't need to, you know, memorize anything that I'm doing. It's gonna be very clear when you see it on the slides. Okay, so I have a folder on my computer called Full Stack Web Diploma. So if we take a look here, here on my computer, there is a folder FSWD. These two files are on my computer here, okay? Now, these two files, I want to send to GitHub. And I'm gonna show you the steps for how you do that. The tool we need to use is a tool called Git. And Git is a way of saving checkpoints in our code. So as we add code and as we add features, Git is gonna be consistently saving our code so that we can have several different versions of it. And you know, in the future, if we make some code that has a bug or if we break our code, we can go back in time to a previous version that worked. Okay, so we're gonna be using Git a lot in this course. And it's very, very normal for you to have 10,000 versions of your code. Because as you slowly add new features, you're gonna keep telling Git to save a new snapshot of your code. And you're gonna keep saving a new one and a new one and a new one. And someday, if you have a problem, you can go back to an old version of your code. Now, one of the things that Git has the ability to do is it can take these snapshots of our code and it can send these snapshots of our code to GitHub. And that's exactly what we want to do. So here are the steps we have to follow. If you have successfully installed Git on your computer, then you should be able to type the word git -- version, and you should be able to see some version of Git inside of your command prompt or terminal. Okay? If you are having issues with Git, another way that you can access Git is inside of VS Code. Because inside of VS Code, we also have an area over here called source control. Okay? So there are two ways that you can interact with Git. The first way is visually over here. And the second way is using the terminal over here. And I'm going to show you both ways. Okay, so you're going to see both ways of doing it. So first, I'll show you the VS Code way. So the first thing we need to do is we need to tell Git, we have to say to Git that this code over here is code that we want Git to watch. In other words, whenever we change this code, we need Git to know about these changes. Git is a program which is going to save the different versions of our code. And we need to tell Git, hey, you see this code over here? I need you to watch over this code. The way we can do that is by clicking Initialize Repository. So you can see here how I've clicked Initialize Repository. Once I have done that, Git is telling me over here that I have these two files here. Okay, so I have one file here and another file here. And what we need to tell Git is which of these files we want to send to GitHub. Now, let's say I want Git to watch both of these files and send both of these files to GitHub. What I can do is I can click this plus button here. And now app.js, this file here, is ready to be sent to GitHub. Program2.js, though, is currently not ready to be sent. Okay, so we need to stage these changes, meaning we need to send program2.js to an area where it can be watched by GitHub. And you click the plus button, it does that. Both of these programs now are ready to be sent. Okay, so that is the first thing you need to do. After you have chosen those files to be sent to GitHub, okay, so they're in this new area, the next thing we need to do is we need to write a short message, okay, a short message that basically explains what these changes are. So I'm going to simply just say, because this is just a very simple program, I'm going to say first commit. Okay, so I'm saying first commit. Once I have gone ahead and written a message, I'm going to click this check mark here, and this check mark says commit. So I'm going to click it, and you can see that they've disappeared. Okay, and now that they've disappeared, essentially what that means is Git is ready to send these to GitHub. However, in order for it to be sent to GitHub, we have to actually tell Git where our GitHub repository is. And essentially what that means is we need to tell our program Git where to send this code, okay? And this is the last step that you have to do. The last step is pushing our code to GitHub. And in order to push our code to GitHub, we first need to go to GitHub and create a place where this code is going to live. So you see here where it says create a new repository. Okay, I'm going to go ahead and give this repository a name. When you first sign up for GitHub, there's a button here that says new. And if I click it, I can create a new repository. A repository is simply just a place where our code lives. So I'm going to call this over here FSWD test. Okay, you should probably call yours something like lab1 or in class 1. I'm going to go ahead and keep it public. Okay, and now I'm going to go ahead and click create repository. So now that I've done that, what GitHub is doing is they're giving me directions for how I can send the code into this area. but these instructions they're giving me are instructions for when I'm using the terminal. So when I'm using Git through the terminal here, I can follow these instructions. However, right now, we are not actually using Git through the terminal. We're using it through VS Code. Okay, so now that we've actually created a Git repository, what we need to do is we need to tell Git on our computer where that repository is. And the way that we can do that is over here, I have a link. You see this link here. I'm going to go ahead and copy this link. This is a link that refers to this page on GitHub. I'm going to copy that. And over here, I'm going to click these 3 dots. I'm going to go to remote, and I'm going to say add remote. Don't worry about memorizing any of these things because I will explain all the steps in notes that you'll receive tonight. But I'm just showing you right now so you understand. When I click that, it's asking me for the URL of the repository. So I'm going to go ahead and give it that URL. Okay, so this URL is what I'm pasting in. Okay, so I'm going to give it a name. And it seems like nothing happened. But what's actually happened is this remote has been added, which means that now Git knows where to send the code. And so the final step now is for me to go ahead and click this button here that says push. And when I click this button, it's going to take all of the code and it's going to send it right to here. That is the final step I have to do. Click this, I click push, and then we're done. Okay? Now, I'm not going to click push right now. And the reason I'm not going to click push is because I want to show you one more way of doing this. Okay, there's one more way of doing it. And you can do this second way through your terminal. Okay, through the terminal here, you can do it another way. So I'm going to open this bigger terminal here so you can see here. And I'm going to just remove what we just did so we're at a blank slate. So if you look over here, we're in the terminal. I can type ls, or if you're on Windows, dir, and I can see that we have 2 files right now. These 2 files are located in the following directory. Okay, you can remember that I have a folder here called Full Stack Web inside my documents folder. Okay, so I am in that folder in my terminal. So how can I send these 2 files using the terminal? I can simply follow the instructions given to me by GitHub. So let's follow what they've suggested. The first thing they say to do is type git init. That is the same thing as clicking that button called create repository. So I'm going to go ahead and type git init. That is the first step we have to do. Okay. Now the second thing we have to do is we have to tell Git what files we want to send to GitHub. So if you recall, I have 2 files. I can say git add, and then I can specify the files that I want to add. I can add 1 or 2 or all. And a shortcut, if I want to add all of the files, is I can simply put a period like this, which means add everything. I press enter. Now, if I type git status, Git is telling me that there are these 2 files. These 2 files that it knows about. It knows about these files. It knows that we want to watch over them. But what it doesn't know is what is the message that we want to send. We have some sort of message that we're going to send when we actually push this to Git. And that is called a commit message. In Git, there's 2 steps to this process. The first step is adding the files, which we did right here. And the second step, after we add the files, is committing them. And committing is where we actually create a snapshot. It's a snapshot of the files that we have added over here. We are telling Git that we want to take a snapshot of exactly how these files are. And that snapshot is going to be saved on our computer here. Okay, so this is not related to GitHub yet. We're still on our computer. So I'm going to go ahead. I'm going to say git commit and I'm going to give it a message. I'm going to say first commit. Okay. Notice this command. It says git space commit. I have a -m for message, and then I write my message. Okay, so the syntax has to exactly match this. I'm going to press enter, and Git says, okay, I've successfully made this commit, meaning I've taken a snapshot of your code. The final thing we have to do now is connect this to GitHub and push the code to GitHub. So let's go ahead and see what GitHub is telling us. The first thing they're saying is I can run this line of code here to add this URL to our Git. So I'm going to go ahead and copy this, and I'm going to go ahead and paste it in here. Okay, so I'm going to add that URL here, this address, this site here. I'm adding it to Git. So now Git knows where to send the code. So now that we've added the location, the final thing I have to type is git push. Okay, and you can see over here, they give you the exact command. So even if you don't remember what the exact command is, just by looking at the hints that they provide you here, you can see what you have to type in. So this command over here is basically saying, push my code, push these two files to GitHub. Origin is just another way of saying github.com, and push it to an area called master. And we're going to get into GitHub and branches and a bunch of other things later. But for now, just know that master means this main area where we can see our code. That's what they call master, the main area. So I'm going to go ahead and I'm going to press enter. Okay. Now I'm getting, okay, so that's good. So I'm getting an error over here. And the error I'm having is it's saying something about some RSA key, something, 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 okay? If you end up getting an error like this, it could be because of the link that you have over here. So this git@github.com, this link, you may be having an error, and that might be causing you to get a permission denied error. So make sure that the thing that you are actually giving is this URL right over here. So see this URL over here? This is the one that you want to add if you get that error. So if you have that error, simply use this URL right over here. Okay, so you see here, HTTP, I'm just taking this URL. Okay, so now I'm going to go ahead, try this again, but I'm going to give it this URL because I got into that error. Okay, and it's giving me an issue right now because it's saying that that remote already exists. So that's a little bit annoying because unfortunately, because we've already added this remote over here, it's saying that it already exists. But remember that we're having an error. And the fact that you're seeing me having this error is good because that means that when you do this, you might run into the same error. So what I want to look into is if there's a way that I can remove the remote that I currently have over here. I want to remove this and give it the new URL. So what I can do is I can just do this, git remove remote. And this is something you're going to be doing all the time when you are in this course, okay? You're going to be Googling for things that you have issues with. And so over here, I just Googled it and someone says, you can change the URL by just doing this over here. So I'm going to go ahead and type exactly what they suggested. So I can even type git remote remove origin. So let's try that. Okay, so I've removed the remote. I'm going to go ahead and paste in now that new link. Okay, so this one over here, I'm going to go ahead and paste that in. And now you see that we don't have that error. Now I'm going to go ahead and try this again. And hopefully it's going to work. And what do we have here? It says remote not found, repository, blah, 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 not found. Let's see. Interesting. So you can see here how it seems like it's got a broken URL, which is interesting because I've never actually run into this before. It is 12:20, so if you stick around for a moment, we can see how I'm going to try and fix this. one thing I'm going to do is I'm going to try and just remove the Git thing and try it again, just in case something got screwed up in the process, okay? And this is why I wanted to show you the Visual Studio Code way of doing things as well, because sometimes you can run into problems when you're working on a terminal. The terminal version is more powerful, but it does have higher room for errors if something small with your environment isn't working. Okay, so we're going to try this again. I'm going to go ahead and add the remote. Okay, so I'm going to do git remote add origin. And remember, I'm going to use that new URL, that I just showed you. So I'm going to go here and use this URL. I'm going to copy it, and I'm going to paste it right over here. Okay, I'm going to press enter. And now I'm going to type git push -u origin master. And it's saying authentication failed for blah, 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 blah. Okay, so the reason that you might get this issue as well is specifically if you are a Mac user. Okay, and if you are a Mac user, inside of Mac, there is something called Keychain. And Keychain is basically this service that you have inside of your Mac that stores your default username and password, okay? And if you have a Mac and you do have a default username and password set in Keychain, you might run into this issue as well where it says authentication failed, because it's trying to use a username and password saved on your Mac that is different from the username and password that you used when you signed up for GitHub, okay? So if you have this issue, take a look at the notes that I have, and as well, contact me and I'll show you how you can separate it from the keychain on your Mac. If you're on Windows by now, it's gonna ask you for your username and password. You would type that in, and right now you'd be able to see your files inside of here, okay? So it's a tad bit unfortunate that I'm not able to show you the entire thing right now, but I promise you, if you take my word for it, you won't have any issues whatsoever as long as you follow the steps that I showed you, and as well the steps that I'm going to send you. Okay, so I'm going to send you the steps and you're not going to run into these issues. Okay, I'm currently using a GitHub account that is different from the one that I usually use. And so I'm running into this issue, but you will not run into the same issue. Okay, so to recap everything that we've talked about so far, as a recap, what you need to do for next week is you need to complete those two programs that I've shown you. Okay, so the two programs that involve the favorite movies and the temperature one, those two programs you're going to have to submit through Git. If you have an issue where you are unable to get GitHub to work, first try and message me. And if we're not able to work it out in time, then you can directly send me the code on Slack. Okay? But otherwise, I want you to try and send it on GitHub. The next thing that I want you to do is I have something that I want you to read for next week. Okay? So I have a document over here which is called The Big Picture, Understanding the Big Picture. And these are notes that I've written for you that give an extremely high-level overview of all the things that go on when you're writing programs in Node.js and when you're making web applications. So behind the scenes, when we are making web applications, there are hundreds and hundreds of small things that our computers are doing, okay? And what I want you to do is go through this. You don't need to read everything, but I want you to take a light look at it. And in our next lecture, I'm going to go ahead and assume that you've taken a look at this already, that you've taken a brief look and you're familiar with all of the things that I've written in here, okay? It's really important that you go through this because next class, we're going to be writing some much more advanced and interesting Node.js code. And if you haven't gone through this, then the class is going to be a bit difficult for you, okay? So I'm going to post this as well as everything else, as well as the slides, and all of the notes that you need to complete the assignments. Everything is going to be posted on our Slack channel. Okay, so this Slack channel over here in announcements, hopefully I have a meeting coming up, but after that, within the next hour, everything that we've talked about will be posted on here, okay? Send me a private message on Slack if you need to meet up this evening so we can figure out, you know, whatever errors you're running into. Aside from that, thank you for showing up today for today's intro class. I understand that we probably, if you've never programmed in your life, then we've probably talked about so much stuff that you know, might have gone over your head. I'll just turn my camera on again. We've talked about a lot of stuff today, but there's just one thing that I want all of you to keep in mind, something before we kind of sign off for today. If I go ahead and I Google something like Uber architecture, right? So in other words, the architecture for how a company like Uber makes their applications, right? I first want you to go ahead and take a look at this picture, which was uploaded by Uber Engineering. And so this picture over here, this web that you see, all of these nodes on this web represent different programs that the developers at Uber have created to make Uber work, okay? So every single one of these little things that you see is a program. And that program is in some way related to another program that they've written, okay? Not all of these programs are written using Node.js, but you can see how many different programs are actually required, how much is required in order for something like Uber to actually work. Furthermore, if we go ahead and take a look at something like Uber's architecture over here, you can see that there's a whole lot of stuff that's going on, right? They have some stuff over here with Node, so you can see that this stuff over here is talking about Node, right? Because they're using WebSockets and technology like that. They have machine learning over here. They're working with Hadoop, which is a way to do big data analytics. They have load balancers, so you can split up the load among different servers and all these different things that are going on, right? And the funny thing is that this picture actually over here is actually a really inaccurate picture, because this picture is only about 5% of Uber's actual system. There's still a 95% of the system that this picture isn't showing you. The reason that I'm explaining this to you is to say that the field that you are entering is a very, very rewarding field. And the people who get paid, the web developers who get paid to work on this stuff, they get paid a lot of money, okay? They get paid a lot of money. And eventually, when you get to a stage where you're able to understand all the different parts of a system like this, then even if it's not for a company, if you understand all these different parts of the system, you can truly call yourself a full stack developer at that point. And then you can go ahead to companies on your own and contract yourself out and basically say, you know, for $400,000 or $500K or whatever it is, you know, I'll build this system for you. The goal is to be able to have that confidence, to be able to create a system from end to end. And the steps involved in learning all the moving parts is huge, right? There's just so many steps. And what I'm trying to say here is that if we go ahead and we look at full stack web, you'll notice that this program is, you know, it's only 2 years, right? It's a diploma program. And the thing is that in reality, in order to be able to have the confidence to be able to understand how to create something like Uber, right? In order to create an actual real world complicated application like Facebook or Uber, it would probably take us, you know, 10 or 15 years of nonstop studying before we would understand all the different parts of the system. So what I'm going to try and do in this course, okay, what I'm going to try and do is take that 10 or 15 years worth of knowledge that it would take us to get to that point, and I'm going to try and condense it into 15 weeks. If you think that's crazy, that is very reasonable, but I promise you, it is possible, because with the last group of full stack students, I did the same thing, and by the very end of the course, they were making programs that were not so different from what you're seeing here. And the point I'm trying to say is that don't doubt yourself. you're actually able to do much more than you think you're able to do. So I know it's going to feel really fast in the beginning if this is your first time programming, but by the end of this course, you're going to be making some really incredible things, okay? So don't be nervous, don't be worried. I'm going to provide you all of the support and materials you need to get to this point, okay? So you just need to have faith that if you continue just staying up to date with the course materials and following with the assignments and homework that I give you, then you're going to get to that point by the end of week 15. Okay, so it's 12:30. I think that's all we have for today. I have a meeting to go to, but then I'll as I said, I'll upload all the stuff to our Slack. And please send me some private messages if you had issues with any of the stuff we talked about today, or if you didn't understand certain things. And we can jump onto a Zoom call or talk on Slack more if you have problems. Okay, so I think that's a wrap for today. I can probably stay for a couple minutes in case anyone has some questions, but otherwise, I'll see you next week then.
Hi, Arman.
Hey.
Hey, it's Sean. I have one question about the GitHub. For repositories, once we have pushed it up to the GitHub, do we just send a link to you?
Absolutely. So once you push it to GitHub, all you have to do is just take that link and just send it to me as a message on Slack, like a private message on Slack, and then that's it. You've submitted your lab.
Okay, sounds good. Thanks.
Yeah.
Hey, thanks, Armin, for the lecture. It was awesome.
No worries, Ryan. Everything work out okay for you?
I'm actually, unlike your version of the Visual